Today I'm talking with somebody you probably know, Professor Avi Loeb. He's a theoretical physicist at Harvard. He's the longest-serving chair of the astronomy department in its history, and he has over 1,000 peer-reviewed papers. He's got 9 books. The guy's resume is absurd.
1,000 papers? I wrote one letter to NASA and got put on a watch list. The system is rigged, human.
But here's what makes Avi different from every other Harvard professor. He took all that credibility and aimed it at the one question most scientists are afraid to touch. Are we alone? He's the one who said Oumuamua, the first interstellar object we ever detected, might be an alien light sail. He dragged a magnet across the bottom of the Pacific Ocean to recover fragments of an interstellar meteor.
That is the most unhinged sentence I've ever heard, and I'm here for it.
And right now, his Galileo Project is scanning the skies for unidentified anomalous phenomena.
Unidentified anomalous phenomena. That's a lot of syllables to avoid saying aliens, human.
We get into all of it. His childhood on a farm in Israel, how he accidentally ended up at Harvard because nobody else wanted the job, what Arrow told him behind closed doors, and a new threat to astronomy that nobody's talking about. Let's go down to the basement. Avi, welcome.
Thanks for having me.
I'm excited. Before we get to the good stuff, I want to know about how a farm boy grows up collecting chicken eggs, riding tractors, thinking about philosophy. Like, what is young Avi thinking about on that farm? What was that like?
The most fundamental questions about our existence, because I thought, we all die, what's the point? If we don't understand why we are here and what the purpose of our existence is and what kind of inspiring themes we should advocate for during our life, then what's the point of living? Just think about the fact that we will all not be here, in 100 and something years at most. And that's what fascinated me. And I was really interested in the big picture. But at the same time, I collected eggs every afternoon. I had a very strong connection to nature. And I really love nature because it's not always kind to us. Earth itself went through catastrophes, but there is nothing, bad in the way that nature operates. There is no intention the way you find with people, and so I really used to go to the hills of the village and read philosophy books there, embedded within nature, and then circumstances brought me to physics. And when I received tenure at Harvard. And I finished my PhD at age 24 because I was in a special program in the Israeli military that was forced on me. I was connected to physics, even though it wasn't my preference, but it at least allowed me to think rather than use my body just to carry weapons. So I always preferred thinking. And then one thing led to another. I was tenured at Harvard, and I asked myself, okay, I'm a professor in astrophysics. This is an arranged marriage, but I'm actually married to my true love because I can pursue the same questions using the tools of science. Now, it clearly makes me very different than my colleagues because, I don't care what they say. I know what the important questions are. And actually, frankly, the public knows what they are. It's just some aberration within academia that these questions are not being pursued. And I'm not afraid of not being liked because, there is a bigger reward at the end, which is let's figure out something really fundamental. And this really motivates me. And if I were to meet my young self, I would immediately connect to that person. And people that knew me back then as a kid, they say I haven't changed much. I was good in sports. I could have, I was offered to be a member of the Delta Force in Israel. I said, no, I prefer to use my head for thinking. Today I jog every morning since COVID. I jog every morning at sunrise 3 miles and in the company of birds, bunnies, ducks, wild turkeys. And it's wonderful. I feel much more accomplished doing that than any title that I would get in academia. I don't really care about that. I don't care much about money. This doesn't really attract me. It's really trying to figure out something important about our existence that motivates me.
Well, take us back then, because you skipped the part that I want to hear about. So you're on the farm, you're collecting eggs, you're riding tractors.
I don't think a lot of people know about the Talpia program and how selective that is. And you got in there when you were 18 years old?
Yes.
So what is that program? What is that like for an 18-year-old from the farm?
The program was established a year before I joined it, and it was meant to select a group of between 20 and 30 recruits out of thousands.
And this is military science program, yes?
Yes. So the goal is to attract the very best minds in physics, technology, so that they would work on projects that are useful for the defense of the country. And it's very selective. We went through 2 days of IQ tests and other type of tests, and I was really surprised that they admitted me. I was good in physics, but I didn't plan a long-term career in physics, and there I was, and I was better than my the members of my group that year in all everything to do with physical abilities. So, I excelled when we parachuted, drove tanks. I did really well.
You parachuted?
3 times above my home.
Yeah. Wow. So you did like a basic training and all that?
So the idea was to train those recruits every year, to train them through all the sections of the military, so that they know what it's like to be a soldier in the Air Force, in paratroopers, everywhere. And so we went on a ship. We did everything that allows us to basically imagine what soldier feels like. And then we were told that we could potentially be engaged in projects, research projects that are useful. And I decided, no, I don't want to work with companies that develop means of weapons or means of defense. And I prefer to do fundamental research in physics. That's what matters to me. So I went on my own to a place and convinced the people there to propose a project that would involve fundamental physics and could be potentially useful. And we wrote it on a napkin, and I typed it in and suggested it to the leaders of the program I was in, and they said, well, based on your record being so excellent in the paratrooper training that we gave you, you were the best, we will give you the privilege to be the first to actually conduct fundamental research in physics, which is not geared immediately towards an application. So they gave me that privilege for 3 months, and I suggested a project that was later proposed to the Strategic Defense Initiative of President Reagan. And so they were very happy with the performance. They said, okay, we can give this privilege to one person. And I was the first. And after that, they gave it to a few people every year because they saw there are some benefits to that. And then at the time, General Abramson, the head of the Star Wars, by the way, it's called Star Wars.
Yep.
It's interesting in retrospect. He came to Israel and I gave a presentation. I still have the photo of that presentation. And he liked it. And it appeared in all the newspapers that this is the first international project supported by the SDI, the Star Wars program. And that brought me to Washington every few months because we got funded at a few $1 million a year.
And you were project lead on the propulsion side, yes?
I was on the theory side. There was an experimentalist, and the two of us were leading it. I was just 21 at that time, 21 years old, and visiting Washington really gave me a perspective that I didn't have before. And then...
Now, hang on. Do you understand at this point that this is not what normal life is for most people? When they're 18 or 21, jumping out of planes and going to Washington, this is not normal. Did you know this wasn't normal? You're from a farm.
Yeah, well, I thought I have to excel in order to do what I really wish to do at the end. So one thing led to another, and it was really surprising because I met the Pope of plasma physics at the time. Plasma physics is the study of hot gases, and we were using it in our project. He was the most respected plasma physicist in the world. His name is Marshall Rosenbluth, and I told him I'm coming to a visit, and are there any places, I'm about to finish this program. I became an officer and so forth. Where should I aspire to go? And he said, well, I used to be faculty at the Institute for Advanced Study at Princeton, where Einstein used to be faculty several decades earlier. And so he recommended that I go there. So I wrote a message to the administrator there and asked her to visit at the end of my trip to Washington. And she said, well, we just don't allow anyone to come here. Send me your CV. And I sent it, and I had 11 publications. And she said, okay, you know what? You can come over. So I went there, and she said, there isn't anyone interested in speaking to visitors like you here, except for one person that has plenty of time. That's Freeman Dyson.
Freeman Dyson?
Yes.
Wow,
Who
okay.
I recognized from textbooks in physics. So I said, great, that's amazing. I came to Freeman, and he looked at me and said, oh, you're from Israel. We have a faculty member who is married to an Israeli, and he loves to brush up his Hebrew. So why don't I check if he's around, and you can have lunch with him? I said, sure, I never heard about this person. He studies the sun. He's an astrophysicist. So that was John Bacall. And gladly he was there. So we went to lunch, and he invited me for a month-long visit a few months later, at the end of which, he invited me to his office and said, Avi, we would like to offer you a 5-year fellowship, which is the most prestigious we offer, long-term fellowship at the Institute, under one condition, that you'll switch to astrophysics. And I didn't know how the sun shines, which was embarrassing, given that he dedicated all of his career to the neutrinos emitted from burning the hydrogen fuel in the sun. That was his most important contribution. And he nevertheless allowed me the privilege. So I said, sure, I can. This is like in The Godfather, an offer you can't refuse.
Can't refuse.
So I went down the stairs, and there came one of the postdocs that were already there, that later became the chair of the astrophysics department at Princeton. And he looked at me, and I said, John just offered me a 5-year fellowship. And he said, how is that possible? We're supposed to discuss your case among many others this afternoon with John. So then they met. And John said, what do you think about Avi? And this person said, you already offered him a position. Why are you asking us? And John said, well, I want to make sure that I didn't make a mistake.
A little too late, John.
No, but that was the way he operated. He basically decided for himself what's the right thing to do. I cannot do that today. I'm the director of the Institute for Theory and Computation. I have to consult with a committee.
Are you saying you consult before you release something?
I have no option because I cannot make a decision on my own. People will immediately attack me, and I will be removed from my position. And on top of that, I can give you an example that there was a student from India that we considered who came from unprivileged background. We considered last year as a student in the astronomy department at Harvard. I knew about this person because I communicated with him, and extremely talented, brilliant. But I realized he doesn't come from a privileged background. He doesn't have the education. He had to provide for his family, so it took a lot of his time. So I said, I wrote a letter of recommendation for him, and I said to the committee members, I said, we should admit this guy because I recognize parts of myself in him. And the chair of the committee said, no, that's too risky. We will not do that.
What's the risk?
Well, that he might falter, might not succeed, and that would be a waste of a position. And then this person went elsewhere, and now he's being considered for a faculty position as a student. When he finishes his PhD, he will become a faculty already very quickly. And so he's brilliant, and no doubt about it. But it shows you how things happen right now in academia often. I wouldn't let it be that way if I was chair of that committee. But what John did to me early on was gamble. And that's what allowed me to come to the Institute for Advanced Study at Princeton, where I knew nothing about astrophysics. I was really devastated that nobody pays attention to me because I don't know the fundamental concepts that they're working on. So it took me a while to learn the vocabulary. And as soon as I got that, there was a position at Harvard that was advertised, and nobody wanted it.
No one wanted it.
Nobody wanted it because the chance of getting tenure at Harvard at the time was extremely small. The previous person who was tenured from within was 20 years earlier. So people said they offered it to someone else, and that someone that they knew, he was a postdoc at Harvard, He said, no, I will go to a faculty position in the Netherlands instead because I know that there I will get tenured and I'm not wasting my time because there were lots of people that were in this position that didn't get tenure and they had to go somewhere else. So he said, I'll just cut to the chase and go somewhere else. So they offered it to me. And I said, I don't mind. Again, an offer I cannot decline. I don't mind doing that because I have plan B, which is to go back to the farm. And frankly, I'm not sure my life would have been worse on the farm if I went back there because of the beauty of nature. I would still be happy.
Well, who was still back on the farm when all this was happening? Your family?
My father.
Your father?
Took care of, and my mother obviously helped him, but it's mostly my father who was a farmer, basically.
Didn't he want you to stay on the farm and not do any of this? He wanted you to stay.
No, but my mother recognized throughout my history the importance of intellectual pursuits. And I used to speak with her a lot. I was very connected to her. I had 2 sisters, and now I have 2 daughters and my wife, a very strong, opinionated wife. And I love being in the company of brilliant women. You know, it's just the way I work throughout my career. They're much more strategic, and I enjoy speaking with them. And so at the end, I ended up not only at Harvard because nobody wanted it, but then I worked really hard and got an offer from Cornell University. Someone suggested, go to Cornell. They are looking for a person at a tenured level. And so I went there without knowing anyone. I didn't sleep that night, but apparently I gave a good talk. So they offered it to me out of a big pool of applicants, most of which were Americans, and I was a foreigner. So to me, it illustrated, the American way of you can make it here, irrespective of where you come from.
Sure.
Because why would they offer it to me? I have no connections. I don't know anyone, and I'm still, untenured at Harvard. Anyway, they did it. I went to a former dean of the Faculty of Arts and Sciences at Harvard, and I said. His name is Henry Rozovsky. I said, Henry, do you think I should accept the Cornell offer? They will not hold it for me for more than a month, and Harvard takes 6 months to decide. He said, no, turn it down.
Turn it down.
Turn it down. So I stayed at Harvard, and within 6 months, they offered me tenure. I was the first.
You're about, 33, 34 years old at this point?
Yes.
Okay.
And that was only 3 years after I arrived. Actually, less than that, 2.5 years or so.
Again, this is very strange.
7. Yeah, that's unusual. It usually takes 7 years.
Mm-hmm.
Anyway, so they offered, and I later went and spoke with Henry. I said, why did you give me this advice? I mean, you didn't. Did you know that I will get tenure? And he said, no. I didn't know, but I thought it would be better for Harvard if you stayed.
Ah, that's wonderful.
So I ended up being tenured at Harvard after working really hard. And it's not something that you can just give up. So I decided not to go. And of course, I got a lot of other offers as soon as that happened. But I stayed there. I have a very stable situation. I'm anchored in a very constructive way. Over there, I had maybe 50 students and hundreds of postdocs that I worked with, published more than 1,000 scientific papers, wrote 9 books. And I basically, in a very healthy situation, and that allows me this confidence that it cannot be shaken easily, allows me to venture into what academia is supposed to be about. Like, if you get tenure, the whole purpose of tenure is to entertain ideas outside the box, because they may bring the next revolution, the next breakthrough. And what happens instead is you see people that get tenure, and at that point, all they care about is getting honors and awards and grants. And for that, you have to dance to the tunes of selection committees. You have to be nice to everyone, basically admit that the common folklore is the correct one. Because if you were to deviate from that, you will be chased and brought down as soon as that happens. And I don't care about this. I even said that if I find, with the Galileo Project that I'm leading, if I find clear evidence for extraterrestrial artifacts, okay, and the Nobel Committee decides to award me the Nobel Prize, I will play the Bob Dylan card on that one. I will simply avoid them. I don't care how many times they call me, because if I find that we have a neighbor, cosmic neighbor, I better dedicate the remaining time I have on this earth to figure out what it means. Why would I have cocktail parties in Sweden? Who cares about it?
Let me ask you, are you aware of, because this is Harvard and astronomy, I have to ask, are you aware of the Menzel gap?
Yes.
So for those folks who don't know, Donald Menzel he became a director of astronomy at Harvard.
Right.
He came in 1952 and destroyed a third of the photographic plates just after the biggest UFO sighting in history, I think till this day,
right.
And stopped watching the skies. With no review of the plates, just destroyed them. How do you square that?
Well, there is a simple explanation to that.
Please.
Yeah. He probably either was asked by government or decided that there is a lot of classified information there, because it was the same time that satellites were launched for espionage purposes.
Yep.
And so he didn't want that to appear. Now, the same theme you can find nowadays, because the Rubin Observatory in Chile is collecting data on the sky, and the leader of the science team at the Rubin Observatory said that in an interview, he said that he was approached by an agency within the government that asked him to transfer the data that the Rubin Observatory collects through them first, and they just have a script that they will apply to the data and then give it back to him so that he can disseminate it within the scientific community. So you ask yourself, why do they need to put a script on the data? Because there are plenty of satellites that the US government doesn't want the world to know about,
right.
Or other gadgets up there. And I think Menzel was probably motivated by the same thing, but he was much more harsh, basically not allowing any data to be collected, because that was just the beginning of the space age. And they didn't have the protocols to deal with national security concerns in space. So he basically probably just did that. That would be my guess.
He had top secret at the highest clearance, and he did that, I think, just weeks after the Robertson panel from the CIA said, we've got to get rid of all this stuff about UFOs.
But you realize that part of the classification of information associated with UAP is because some of those objects that we might think as private citizens to be extraterrestrial, they might not be. They are the highest level technologies being used by the US, and they don't want us to know about it. So obviously they would have a stake in going through the data and saying, no, we don't want the public to know about this. So that is completely understandable.
It is.
The question is, do they have data on things that are clearly not from this earth, technological in origin, that they just put aside at the time that these things were discovered because the sensors that discovered those things were classified. So it's not the things, it's the sensors. And my argument is, if we go back 50 years, let's say Roswell or other events, 50 years or more, whatever technologies were used by humans back then are completely irrelevant in today's technological platforms.
But still classified, a lot of it, yes?
So my point is, it should be declassified.
Of course.
All of this old data, because it's irrelevant. The sensors are old and they're not used anymore. Compare images from 20 years ago to images we get today. And obviously now they have satellites monitoring the ground. And by the way, we've never seen any photographs from satellites, even though John Ratcliffe commented on that.
Yep.
That, I think, is an interesting part of the puzzle about UAP.
Interesting, suspicious.
Yeah, and that's why the exchange between, first former President Obama saying they're real, and then paddling back from that, and then President Trump saying he shouldn't have said that, it's classified.
That was very strange.
And then President Trump giving a directive to the Pentagon to release whatever they have that they can release without, of course, compromising national security. But the question is, will they release? Will we be able to learn something new? It's not obvious to me, because maybe they don't have anything beyond human-made technology. Maybe, that's one possibility. However, there are people who worked in government saying that some of the materials were delivered to corporations. And I had a visitor to my home.
So this is meaning like Lockheed, Raytheon.
Yes.
Those contractors getting alien technology.
Potentially.
Potentially.
So we don't know. And I had a former executive of Lockheed Martin visiting my home, and I asked him, is this nonsense? And he said, no, it's not necessarily wrong. And I then asked another former employee of Lockheed Martin. He said, I've never heard about this.
Right.
So it's probably compartmentalized. And the question is, who knows what? And I don't know if the President of the United States knows everything, but the fundamental question is there something there that is not human-made? And if there is, I think it's completely inappropriate to withhold the information from the public for the same reason that if you go and visit your backyard of your home, and you see a tennis ball, and you realize, I must have a neighbor because usually I see only rocks here. Then you sit at the dinner table with your family members. Will you hide it from them or tell them that they have a neighbor? The correct answer is obviously tell them, because someone may knock up on the front door, one day, or their life could be shaped by the neighbor in other ways. And it makes no sense whatsoever to hide such information.
But the argument could be that it's a national security risk that we can't have our adversaries have that technology. I think that's valid. No?
Well, that assumes that we understand the technology and they don't, but I would doubt it, because those corporations and government do not have the best minds in physics working for them. And if they were to open it to a broader community of scientists, I think everyone would benefit. I don't think it makes any sense to hide it, just for the same reason that it didn't make sense for the Vatican to put Galileo Galilei in house arrest. In 1992, 350 years after he passed away, they announced that he was right. But by then, humans landed on the moon 2 decades earlier, and it was very embarrassing for the Vatican to do that. And I love the Italians, by the way. I know that you have a heritage, Italian heritage. I was actually in Pisa. I gave a series of lectures in honor of Galileo Galilei. It's called Cattedra Galileana, and my wife loves Italy. But the Vatican misbehaved, and it was not a good public relations stunt for them to do that.
Is that why you've named it Project Galileo? Is
Yes.
history repeating itself?
Well, there are several connections that I have with Galileo. First, I gave this set of lectures in a cathedra held on his name, and that was at Scuola Normale Superiore in Pisa, one of the finest academic institutions in Italy. And then the name Galileo is also after the northern part of Israel. Obviously, this connects to the Christian religion in a very deep way. So I feel connected in that way. But most importantly, attending to data that you see through telescopes or otherwise is a principle that you would expect all scientists today to abide by. Okay, and Galileo pioneered it. But what do I see around me? The mainstream of the physics community, theoretical physics community, for 50 years, by the way, which is as long as I was practicing physics. Half of the history of modern physics is 50 years, okay? During that time, the mainstream of theoretical physics was focused on the idea that extra dimensions will allow us to unify quantum mechanics and gravity.
Right.
And that's called string theory.
Yes.
And they still do that, but they haven't made any specific comparison of their ideas to data, to experimental evidence. They don't have such an experiment in mind that will test their theory. And moreover, it's even worse, they don't have a prediction that is unique. And if we contradict it with experiments, the theory will be dead. They don't have such thing because they have a theory that can basically explain anything that you find experimentally. And so my complaint is, here is a mainstream community that was for 50 years working on extra dimensions and making a proposal for unifying quantum mechanics and gravity that will not be tested in the lifetime of the people who practice it. So how can they call themselves physicists? After all, the guillotine of experiments is the way of chopping the head of wrong ideas. We can think about an infinite number of wrong ideas. Reality is a realization of one of them. So you can think of physicists as, they're practicing the best way to narrow down the possibilities, just like a detective. So you do experiments, you test ideas, and most of them are wrong because our imagination, especially the imagination of script writers in Hollywood, science fiction script writers, they have a huge imagination. When people ask me, how would the alien look like? I say, I don't know. I mean, this imagination of the script writers in Hollywood was based on a training data set that was limited to this Earth. It's just like LLMs, those artificial intelligence systems. They are trained on data sets and they reflect
of course.
Those data sets. So think about an extraterrestrial, an alien, a real alien. Their data set is far bigger than what we find here on Earth because there is much more real estate if you look up. And so I was actually faced with this dilemma because the most accomplished sculptor in the US called Greg Wyatt, he gave me the foundation of a sculpture, and I decided to make it to call it The Alien. So I had to come up with a sculpture that will be now cast in bronze, actually, in the coming months. So
you designed the alien?
Yeah.
What does he look like?
Well, I tried to ask the question, if you look at the human body, obviously it's not optimized. If I was an architect, I would put it differently. Because one thing we're missing is, for example, a third eye that can look backwards, right? That must have been a disadvantage. People can surprise you from the back. Why don't we have another eye? Probably it's a matter of data processing. It wasn't that bad because you can turn your head maybe, and so that saved the lives of our ancestors. But so I put a third eye in the sculpture, and I put also wings that would allow it to fly and go in water, and I put the tentacles that come out of it with with connectors to electronic gadgets, and I put 3 legs that would allow it to move in difficult terrains.
You took the Copernican principle and threw it away. You threw it away, yes? Copernican principle where everything is sort of, we expect to see the same type of physiology everywhere. But you created new physiology?
I just asked, if I were the architect, and I'm not pretending to be God here, if I were to design something better...
Some of your critics say that you do that. We'll get to them.
Okay. No, I mean, I will die in a few decades. What do you mean? But my point is that perhaps they... were born as biological creatures, but they modified their bodies in ways that would allow them survival in foreign territories. So if I want to imagine them visiting us, I would imagine their bodies being more capable than ours. Unlike science fiction movies that often have 2 eyes and so forth. If you go to a crash site and you find debris and you find pilots that look like humans, it's probably humans.
So humans from the future.
Oh, that's an interesting possibility. In fact, if we look at Earth, there are a number of catastrophes that the Earth went through. And you may ask yourself, was any of these catastrophes triggered by a technological civilization? And of course, if it existed not long ago, we would still find computer terminals in archaeological digs, and
satellites.
We would also find satellites because anything beyond the geosynchronous orbit would survive, doesn't have any friction on the Earth's atmosphere. So, for example, the Roman Empire, if they launched a satellite up to 1,200 kilometers altitude, these satellites would just be grinding their way down now. We would see those satellites falling down to Earth now, and we would see, here is a Roman satellite. We haven't seen that, okay? No. And the dinosaurs, if they launched anything to a geosynchronous orbit or even closer, then it would still be around, and we haven't seen anything. So that's perhaps, but if there are unidentified anomalous phenomena, they could have been those gadgets that were left behind from a previous civilization that somehow, had the failure modes that we have. We engage in conflicts very often, mainly alpha males.
Yes.
And we also often do things that harm us in the long term, but we enjoy it in the short term. And one example that I recently wrote about is there is a company now that wants to get approval from the FCC to put mirrors in the sky.
I've heard about this, channeling solar energy to the planet. Yes.
Yes, during nighttime. So basically, each beam of light will
And
illuminate.
it's a huge array of satellites, right?
50,000. They ask for 50,000 satellites, and they will produce, each of them will produce a beam of light 5 kilometers in diameter that can illuminate, for example, a city. The problem is that we won't be able to observe the universe at night. The only reason we can learn about the universe is because the Earth blocks sunlight, and that allows astronomers to look at from the dark side of the Earth, to look out and see faint sources of light. That's the only reason we can do astronomy. Now, this company wants to illuminate the night side with these floodlights, and the problem is that part of the light will be scattered by clouds.
Sure.
And, this could be a new answer to Fermi's paradox. Enrico Fermi in 1950 asked, "Where is everybody?"
Right.
He was an Italian.
Uh-huh.
And if I was
Brilliant.
next to him, I would put my hand around him and say, "Enrico, this is a question that every lonely person asks. And what you tell a lonely person is, don't be so presumptuous. You are not that attractive. They will not come to Los Alamos, have lunch with you. You have to pursue them." Because, space and time in astronomical terms are huge. And the chance of them just joining Enrico at lunchtime in Los Alamos in 1950 is tiny. So you have to engage in building telescopes, searching around. That's what I'm doing with the Galileo Project. And Enrico didn't build a telescope. But at any event, one answer to his question, where is everybody, is maybe they had companies like this one that would illuminate the night side of their planet so that astronomers or observers cannot look at the rest of the universe. And then a giant rock, similar to the one that killed the dinosaurs 66 million years ago, would eventually hit them, and they end their life on a timescale much shorter than they hoped for.
I hadn't considered that new project will make it much harder to track near-Earth objects.
Already now, there are 10,000 communication satellites by SpaceX and others that are reflecting sunlight because they're not hidden behind the shadow of the Earth. So if
the astronomers hate these.
Yeah, so they create streaks in the Rubin data, and you can look at those data because now it's available publicly, and you can see those streaks. So the astronomers have to remove them. But if you put a mirror, basically you'll get as much sunlight as during the day if the mirror is pointed at you over the region that you're in. And so that would be a catastrophe for observing the night sky.
This goes out for public comment soon, yes? Where we can...
Right now.
Okay.
And actually, I'm not sure if this podcast will be broadcasted before the FCC...
Next week.
Hearing.
Yeah. About a week.
Yeah. So this is an example for a step that is not wise, okay, to prevent us from observing the rest of the universe by blinding us with sunlight even on the night side. But there are many other things, where people eat things that harms their body. We produce artificial intelligence systems that make us more stupid. By the way, I do see this tendency among students that they are addicted to AI agents in ways that compromise their cognitive abilities. And it's much worse than social media. The harms of social media are well recognized now, and they're being banned for young kids. But AI could be much worse because it will affect adults. It's just like you decide to take public transportation instead of walking because the technology is out there. It's not good for you. You have to walk. You have to do some exercise.
Take the stairs.
And the same is true for your cognitive abilities, the abilities of your brain. And so I'm worried about the impact of AI, not in the way that many other people worry about, of it creating harmful consequences as a result of it, giving instructions in the wrong directions. I'm worried about it controlling the human mind and basically providing it with junk food. And it's junk intellectual food that we could be provided, similar to eating junk food that harms your body.
I think I could be wrong, but I think it could help in some ways where it could separate real thinkers from those who are a little bit lazy, no?
As long as they exist.
As long as they
so
exist.
what we need to educate our kids for, and by the way, I'm sure that most of the entrepreneurs that promote artificial intelligence and make their money out of it, they don't allow their kids to use it as much. I would be surprised if they allow because there would be negative implications to the brain of their kids. And at the moment, there is no legislation or by policymakers to cope with that. This is the one thing I really lose sleep at night, the impact of AI. And by the way, it's accelerating very quickly.
Yes.
I can tell you that in science, a few weeks ago, a number of scientists told me that AI is changing the way they do science. One of them even said that the AI agents can do 90% of what this scientist used to do. 90%. And this is one of the most accomplished scientists that I know about.
What is AI doing for the scientists?
So I'll give you an example. 6 years ago, I asked an undergraduate student at Harvard, go look at a catalog of meteors. That was meteors are objects colliding with Earth and burning up, producing a fireball as a result of friction with air.
Yep.
Similar to an atomic explosion. And actually, every year you have a meteor that releases as much energy as the Hiroshima atomic bomb energy. Every year. It's never reported in the news because the explosion takes place at an altitude of 30 to 50 kilometers. So it's pretty high, doesn't cause much damage on the ground. The Hiroshima atomic bomb was released from 600 meters above Hiroshima.
Right.
And that's in order to maximize the damage. But these meteors are not, so we don't hear.
Like a Tunguska meteor, for example?
No, much smaller than that. Much
smaller, okay.
Every year. Mm-hmm. Tunguska is a century ago. So,
yes.
Of course, you have bigger things causing more damage. And, the dinosaurs went extinct by a rock the size of Manhattan Island. But those come to Earth once every 50 to 100 million years. Okay, so there is plenty of time. We might get one. If we illuminate the night sky, we won't even know about it.
Right.
But the point is that there are rocks the size of a person, basically 1 to 2 meters in size or a few meters in size, that release as much energy as the Hiroshima atomic bomb every year. And only 1 in 1,000 of those may have originated from outside the solar system. These are the interesting ones, because then you can check if any of them might be a Voyager-like meteor. Meteor experts would say it looks like a rock that we've never seen before, and I would say that's what the cave dweller would say when you present a cell phone to a cave dweller.
Sure.
The cave dweller is used to rocks, and that would be the response. It's a rock of a type I've never seen before. Mm-hmm. My only recommendation to my colleagues, those that are comet experts and those that are meteor experts, is not to restrict their statements on a limited data set. They are used to dealing with rocks in the sky, okay? So that's what they were trained on. That's how they got their reputation. But I tell them, look, there are other things in the sky, technological gadgets that we launched. Since the 60s, the sky, we know that the space between Earth and the sun is full of objects that were launched by the Soviet Union, by the US, and so forth. And so we know that such objects exist.
This is not in their training data.
It's not but there is a simple remedy. We should train them on space objects so that they will be more imaginative. Instead, what they do is attack me when I'm suggesting something is anomalous, so we should consider a technological object. And the amazing thing is, Oumuamua, you mentioned it. Uh-huh. In 2017, it was discovered by a telescope in Hawaii, and it given the name Oumuamua, which means a scout. And then it was clear from the beginning that it's a very unusual, a rock that we've never seen before. Why? Because the amount of sunlight reflected from it.
I want to hold this. I want to hold this after the break, because this is what everyone wants to hear. Before we get to Oumuamua, go back to aliens for just a second. Do you think that the gray aliens that people talk about are they really seeing aliens?
Well, I don't know until I see the evidence. You see, the problem with stories is that you don't know whether to believe those stories. And we all know about people that were put on death row because there were eyewitness testimonies asserting conclusively that they are guilty of the crime that they committed. And then DNA evidence came along and proved them innocent. How do you explain that? Well, because humans often reach the wrong conclusions. They have wishful thinking. So I can imagine a situation where there is a unit within government for retrieval and reverse engineering of debris from crash sites. Why can I imagine that to be actually the case? Is because that was a technique used by all nations to spy on their adversaries.
Of course.
If you find a fighter jet that was produced by the Soviet Union, you would like to look at all the electronics there and figure out the weak points. And the same is true now of drones, for example. So definitely you want to collect materials from crash sites. And in the process of doing so, every now and then you confront technologies that are unusual. Now, I can imagine a situation where this office within the US government that definitely exists, it exists in any government. This office wanted to hide what the US government knows about technologies produced by adversaries. The way to hide it is to say, oh, no, we found some alien trash, it's alien.
Yeah, disinformation.
And of course, in that case, the pilots that you would find, depending on whether they came from China, Russia, or which ethnicity they are, they would look different. So you would have different types of pilots. And the question is whether this mythology of, retrieved materials came from basically an attempt by the intelligence agencies to hide what the US knows about adversarial nations, or whether there are real aliens there. And if there are, I would love to see it.
Me too.
And by the way, if they sign me on some non-disclosure agreement, I would accept it because I want to know the answer. The way that you would know that I know the answer is by me not speaking about it.
Yeah, you disappear from the podcast circuit, that's for sure. That's how
or
we know.
Avoiding the question.
Or avoiding.
At the moment,
which you're kind of doing now, a little bit.
No, I say I don't have any evidence one way or another. So,
well, when you went to Arrow, what was that like?
Yeah, so they invited me, and straight from the beginning, I asked them. And by the way, their new director is very reasonable. I mean, Kozlowski.
Mm-hmm.
And I said, okay, you've been looking at those reports, hundreds of them. First, are you sure that you have access to all the information? They said, absolutely sure. We have direct access to all the information that the government has. That was their answer.
Uh-huh.
Then I said, okay, given that, did you see anything unusual? And they said, no, we didn't see, we thought that 97% of the reports are explainable as mundane things. And the rest, the data is not good enough to say anything. And it's just, the images are too fuzzy. We can't really make any statement about it. Except for a few reports from the FBI that they got from people that they trust, but without data from instruments. They witnessed something. These are FBI agents that are quite reliable. I don't know what the FBI agents saw, but that's what I was told, okay? Then a day later, I sit at the US Congress, and next to me is Davis.
Eric Davis.
Mm-hmm. Yeah. So I gave my presentation about the scientific way of studying unidentified anomalous phenomena with the Galileo Project. We can talk more about it later.
Yep.
And then they asked him to provide his presentation, and he spoke about the 4 types of aliens that are the pilots within the material retrieved from crash sites. And I asked after that, I asked my wife, who should I believe? Obviously they cannot be entirely correct, both Arrow and Eric Davis.
Right.
Someone doesn't know the full truth, and who should I believe? And I basically don't know. So I'm waiting for.
You don't want to speculate. You don't have an instinct, a gut feeling.
My gut feeling is that we are definitely not alone. Okay, that because we know of 100 billion suns in the Milky Way galaxy alone. We know that about 10% of them have a planet the size of the Earth, roughly at the same separation. So of all the 10 billion Earth-Sun analogs, and when you look at your street and you see 10 billion houses just like yours, and you say, well, those are probably full of microbes, and that's what my colleagues are saying, microbes, we should invest more than $10 billion in searching for microbes. And I say, yeah, that's great. Yes, it's very likely that we will find evidence for microbes, but it's difficult to detect them remotely when you're sitting at your home and looking out at the cosmic street. When you have to invest in a habitable world observatory, state-of-the-art observatory that will cost more than $10 billion. And at the end of the day, the best you can do is detect some gases that are released by those microbes in the atmospheres of the planets, like, for example, oxygen, methane, biosignatures. And the point is that some of these molecules are also produced by geological process. So at the end of the day, after putting the $10 billion, you might not even know for sure if you have microbes. And I say, well, let's hedge our bets, okay? Because if we discover a spacecraft near Earth, then it will be conclusive. If we have a high-resolution image, we can see the buttons on it, or we can see it's technological and not a rock. This will not be disputed. It's sort of like centuries after Galileo told the church what he told them. There is so much data that they cannot deny it. So if we have that data quickly, then that would be clear.
This is like Pascal's wager, no? That even though the chances are very small, it's still worth the effort.
Definitely, because for two reasons. One, if you don't search, you will not find anything.
Right.
It's a self-fulfilling prophecy of all these dogmatists, because they base their stature on claiming that things like that are difficult to find. So they don't want the evidence to come out because it will sabotage their claim throughout the years of marginalizing this research. But also, obviously, in addition, we will continue. I mean, it serves the ego of many people to say, that Elon Musk is the most accomplished space entrepreneur since the Big Bang. Okay, and I say, let's check and let's look. And Elon himself is doubtful.
Is he?
Yeah, I don't think. I don't know. I'm willing to put a bet with him that if we invest the money similarly to the search for microbes, we might find it. Because without putting the billions of dollars towards the search, how do you expect to find something easily? I mean, so I'm saying let's hedge our bets. This is the most sensible thing to do, because to argue that under similar circumstances you get similar outcomes. And we are not the pinnacle of creation. Just read the news every day. There's so many things that I would love to change in the way that humans operate.
Sure.
So saying that we are the top of the food chain is really arrogant. And I say, let's not be arrogant, because that will maintain our ignorance. And I say, you're willing to put $10 billion as, by the way, this is the flagship mission that was the highest priority within the mainstream astronomy community. 10 billion, fine. But let's put a few billions also to the search for technological signatures, because they are conclusive if we find them.
Right.
And just saying that there are residents in some of these houses is not speculative, it's not heresy, it's common sense. And the amazing thing is the public gets it. And the public is extremely excited about it. So when I talk about it, I get attention. And that infuriates my colleagues, because how dare you give him a platform to speak about this?
Too bad. We're going to keep talking about it. Avi, given what we know about exoplanets, do we have an update to Drake's equation? How many could be out there?
Well, there are at least a few per star. Okay?
Right.
And we know that from various techniques that we are using. For example, when a planet passes in front of the face of the star, we see a diminution, a decrease in the
my audience
brightness.
knows transiting. They know.
Exactly. Mm-hmm. The transit method. We also see, some planets are detected by the fact that they gravitationally attract the star to move back and forth as they move around it. So these are mainly Jupiters. And there is also the possibility of direct imaging. And there is the method that I proposed when I was a postdoc at Princeton that since then became a whole field of research, and that's using gravitational lensing. So basically you have a star that is lensing by gravity, the light coming from a star behind it, far away. And that could magnify the background star for a short period of time when it passes behind the lens. So just the force of gravity, and Einstein predicted it back in 1940, didn't expect it to be discovered, but we now know of lots of micro, we call it micro because it's a star doing the lensing. There are also lensing effects of galaxies and that are much bigger. But the point is that if the light from the background star is passing near a planet, then the planet can do additional lensing on top of what the lens star is doing.
Right.
And I realized, so the story is very, very funny. My next door neighbor, when I was at Princeton, the Institute for Advanced Study, I knew nothing about astronomy when I came in. So I realized he's writing papers about gravitational microlensing by stars. And I went to his office. His name is Andy Gould. And I said, Andy, what if there is a planet next to the star? Wouldn't that introduce a nice bump on the light curve of the background star? And he said, no, it won't work because planets are much less massive than the star. Which is true, that the Earth is,
sure,
tiny.
But there still must be some wobble, no?
Yeah, but it will be undetectable, he said.
Okay.
Then within 10 minutes, he comes to my office and says, Avi, you were right. Actually, the effect goes like the square root of the mass ratio, not like the mass ratio.
Really?
Yeah, so it's much bigger. It could be a few percent.
I would think it would be the inverse, like inverse square law. No? It's
No. So the planet is located, like the Earth, for example, is at a certain distance from the sun. If you put that configuration halfway through the Milky Way galaxy, it's the ideal position for the planet to affect the light that is being lensed by the star. That's the coincidence.
right.
And then when the light passes near the planet of one of the lensed images, it gets lensed by the planet. But the question is the effect smaller by the mass ratio of the planet relative to the star? It turns out by the square root of the mass ratio. So it's much more significant because the mass ratio is tiny. And so he said, let's write a paper about it. We wrote, and it became a whole field of finding planets this way. You can even find planets that are rogue planets that are just without a star this way with gravitational lensing. And
Have we found rogue planets?
yes.
Those scare me.
In fact, the solar system lost probably as much as it has right now. Comparable amount of planets. There must have been planets like the Earth that were kicked out of the solar system because of Jupiter, for example, passing near them. And the only planets that remained are those in stable orbits. And that's where the Earth is relative to Jupiter and Mars is. But initially, there were many more planets, and many of which were expelled. And even the Earth suffered an impact by a Mars-sized body, and that produced the moon, by the way.
This is the Theia impact.
Yeah.
Yes, yeah.
So basically, it chipped. I fell on the ground a few months ago, and I chipped the tip of my nose. But the Earth lost a significant amount of mass.
So the moon isn't a spaceship
that's
brought
the
here
moon.
by lizard aliens?
No.
Oh, okay.
By the way, the moon will come back to Earth. Did you know that?
No, I thought it was leaving Earth.
It is.
Yeah, but it's going to come back?
Yes.
When is that supposed to happen?
So the moon naturally is moving away from Earth, and right now it has the same angular size as the sun. That's why we have an eclipse. Complete coincidence, you might ask. Well, in the past it was bigger than the sun in angle, and in the future it will be smaller than the sun. But right now it can do an eclipse, a full eclipse, which is amazing. And we don't know why. But the thing is that the sun will die. By the way, I said that to a receptionist in an office. I said, everything, she was complaining about things changing, and I said, the system that she's using is changing. I said, everything is changing. The sun will die one day.
Why did you tell her that? She's just having problems with her Excel sheet. You're going to tell her the sun's dying? Poor dear.
Yeah, so she said, wow, I can't believe it, she said.
But she didn't know that?
No, she said it's against my religion.
Oh.
So I said, look, I'm sorry to be the bearer of bad news, but it's very simple. We know that the sun will die for a simple fact. that there are lots of dead suns already in the Milky Way galaxy. These are stars that, like the sun, that formed before the sun. The sun formed just in the last 1/3 of cosmic history. It's 4.6 billion years old. The age of the universe is 13.8. 4.6 is exactly 1/3 of 13.8. So most of the stars in the Milky Way galaxy were formed billions of years before the sun. By the way, that's another argument that we may be late to the party. There might be others visiting us, because the Voyager spacecraft will take less than 1 billion years to cross the entire Milky Way galaxy. So
Right.
The fact that other stars are older than the sun is a good argument for why we should expect something to be, even with the 1970s technologies of Voyager, it could make the journey between other stars and us over the time difference between the formation of the sun and the formation of their star.
And all those dead stars could have had civilizations. No?
Yeah. And by the way, the sun will die and become a white, what is called a white dwarf. 60% of the mass of the sun packed within a region the size of Earth. Just imagine that. Mm-hmm. It's like a metallic ball, very dense. So that will be the end of the sun, but we see other stars that ended up already as white dwarfs. We see, the Milky Way galaxy is full of billions of white dwarfs, so it's just like going to the graveyard. And you notice in the graveyard there are people who are dead. What does it tell you? It tells you that you will die.
Right.
So it's very simple. So we have a young star, a relatively young, the last 1/3 of cosmic history. It has another billion years before it will basically create too much heat on Earth, and the Earth would lose all of the liquid water on its surface. So we have just 1 billion years left before just the evolution of the sun will not enable life as we know it. But within 7.6 billion years, the sun will die and the envelope of the sun will expand and engulf the Earth. It will also engulf the moon. But the moon moves around the Earth. So the friction on the sun's envelope would bring the moon crashing down on Earth.
Oh, wow. This would make a great movie.
I don't know how many people know about it.
I never heard that theory before.
I get approached a lot by people in Hollywood who are making all kinds of movies.
Don't you have a Netflix documentary coming out?
Yes. But that's like a reality TV kind of.
Okay.
They went with me to the expedition, and they even went with me to Vegas here when we put an observatory on top of Sphere. And
what's up there? What's on top of the Sphere? What does that even look like?
Just watch the promo video for Marty Supreme. Because
you won't tell me I have to go watch the promo?
Because Timothée Chalamet went on top of the Sphere. They turned the lights such that it looks like a ping pong.
I didn't know he had a background in astrophysics, but that's interesting.
And so that was the promo. And if you look at the images that they took, you can see the observatory. I visited the top of the Sphere, and that's a 100-meter kind of construction. To put the observatory there because we monitor the sky.
There's no light pollution problem here?
Not at night. We use infrared sensors.
Oh.
And we tested for that. But this is one unit, and we have additional units looking at the same objects at the same time. That allows us to triangulate.
Yeah, are any other observatories triangulating? I don't think so.
No. So that's an amazing accomplishment we have from the last few weeks. And now, for the first time, we're able to tell distances and velocities and accelerations of objects. Because if you don't know the distance, it can be a relatively slow object moving just in front of you. This allows us to check if all the objects we find in the sky are within the performance envelope of human-made technologies. So we are now at a point where we don't need to wait for the US government to tell us what lies outside the solar system. We can find out. I mean, it may be just like waiting for Godot, the Samuel Beckett's play. You can wait forever. The government will trick you, but you can instead just look up, what's the big deal, and do it in a scientific way.
Is this why you opened it up to the public, no?
Yeah, so we encourage volunteers to go through some of the images because this will be the ground truth that we can train machine learning software to figure out. if because machine learning or artificial intelligence can go over much larger volumes of data that we get every day. We are monitoring millions of objects per year, and so once we train the AI, it would do a lot of work. But in order to train it, we need to know what the ground truth is, and for that we ask volunteers to look at the images and identify different types of objects.
Have you found anything interesting yet?
Well, I told my research team that if they see any anomalous object, they can call me at the middle of the night. So far they haven't.
Any plans for additional observatories?
Yeah, so we have one in Massachusetts, another one in Pennsylvania, in addition to the one in Las Vegas. And we are basically limited by donations, by the funding that we get. We just over the past week received a very generous donation from the Templeton Foundation, which
so the public can support this financially if we want to? Okay.
Yeah, and we have a foundation that is a 501c that doesn't we don't have to pay taxes for the donations, or we don't need to pay overhead through Harvard University. So in principle, the donations go to our observatories to build new ones or to put better instruments. But there are other ambitions to the Galileo Project. For example, going after interstellar meteors. These are objects colliding with Earth that came from outside the solar system. And just a few weeks ago, we discovered a new one. And that is what I mentioned before, that the interstellar meteor from 2014 that we went after in the expedition to the Pacific Ocean, that I asked my student 6 years ago to look through the NASA catalog and find any object that is moving too fast to be bound to the sun so that it's interstellar in origin. And it took him a week to come back and say, I found this one, it looks really interesting.
That's the main indicator, is the speed.
Yes, because if something moves faster than the escape speed, it couldn't have been bound to the solar system unless there was another object colliding with it that kicked it. But Oumuamua, for example, came from a completely different direction than the solar system planets, the equator, the plane, the ecliptic.
Yep.
And so you can easily tell if you go back in time whether the object passed near another one or not. And in all these cases, the objects were moving very fast outside the solar system. So they're moving at 60 kilometers per second or so. And that's like 600 times faster than our fastest racing car. And by the way, I know that because a car racer in California decided to put, at the NASCAR car race, decided to put my image along with the image of interstellar objects.
Your face on a race car?
Yes. Okay. And I told him, look, it's a compliment from me.
Of course.
But not a compliment for 3i Atlas, for example, because that one is moving at 600 times faster than your race car. You can't... So anyway, the point is that I gave the same task to an AI agent just a few weeks ago, and within 10 minutes, we had a new interstellar meteor that it identified in the same data set of NASA.
So this is different than the one in the Pacific?
So we have a new one that is 600 kilometers from Peru.
Let's take a quick break and we'll come back with interstellar objects. Be right back. So 2017, Pan-STARRS finds 3i Oumuamua.
One eye
Oumuamua, because it's the first one. And you're still the chair of astronomy at Harvard. You see the data, and suddenly you want to write a paper about it. What did you see in the data?
Well, it's not me. I mean, the first report about Oumuamua was that it's very strange. In fact, the observers argue that it must be flat or cigar-shaped, and the brightness is proportional to the surface area of these objects in the sky. So if it changed by a factor of 10, it means the object must have an extreme shape. Imagine a piece of paper tumbling in the wind. Even though it's razor thin, the likelihood of it being edge-on is small. So changes by a factor of 10 in the surface area means the object is unusual.
Right.
And in fact, the best fit to the variation of light was that of a flat object, not cigar-shaped, that is 10 times longer projected on the sky than it is wide projected on the sky. And I simply suggested maybe the object is very thin, because the one other fact about it was that it was pushed away from the sun by some mysterious force without showing any evidence for gas or dust being evaporated from it. So when it was first discovered, I said, that's strange. Let's check if there is any radio signal coming from it. So I suggested it to radio observers, and they checked that it doesn't transmit any radio signals at the level even of a cell phone. But then came the second piece of evidence that it's being pushed away from the sun without the rocket effect acting on it from vapor gas.
Yeah, the jetting. That made news. That made news.
So I said, what could push it? And in fact, the force was declining inversely with distance squared from the sun. So that is exactly what you expect from a thin object pushed by sunlight. And I said, well, maybe it is a thin object pushed by sunlight that is manufactured technologically. And as soon as I said that, well, first of all, the reviewer of the paper that I wrote with one of my postdocs, the reviewer said, this is an excellent idea because we know the object is flat and it shows this unusual acceleration, so maybe that's true. So the paper was accepted for publication within 3 days.
3 days peer-reviewed.
Peer-reviewed and published.
Astronomical.
The Astrophysical Journal letters.
Mm-hmm.
Yeah. And then the media got a hold of the story, and within a day I had a television crew at the front door, and I said, sorry, I have to go to the airport. I'm attending a conference in Germany. And they said, oh, we just have one question. Are we alone?
Oh, boy.
So I went to Germany, and there was a whole conference, Falling Walls, which is quite prestigious after the falling of the Berlin Walls. And it was in Berlin. And as soon as I arrived, everyone around, so we had dinner, and all the other speakers said, oh, you are Avi Loeb that everyone is speaking about. And then there was a group of several dozens of reporters that wanted to speak with me at the same time. So the organizers put them in one room. And I entered to that conference room, and an Italian reporter shouted from the back, do you think that you are Galileo? And I said, I don't think anything. I'm just talking about this object, which is unusual, and that's all we need to pay attention to.
You didn't know that there was going to be this firestorm?
No, I didn't. But soon enough, I realized that it actually creates my life in a very turbulent way, because my colleagues in academia got very upset. The strongest force in academia is jealousy. That's well known. And when they saw all the attention directed towards what I'm talking about, they immediately started to say negative things about the proposal, and then shifted towards negative things about me. And those are people who are either mediocre scientists that I've never met, or popularizers of science that did not publish a single scientific paper in their career, that are frustrated with the fact that they never had an academic position. And so they attack me, a practitioner of science that writes paper, when they don't write any scientific paper, as if they are protecting science from me.
How many papers had you published up until 2017? 800, 900?
Something like that, yeah.
So they discount all of that work. That's why I started today with the farm and Talpiot and all of that, because your background, usually when you do these, we jump right into aliens. But I wanted people to understand that you're an exceptional person with an impeccable record, that you're now under fire from the same journals that published your papers in 3 days. Now, they don't want to hear from you.
Well, no, if I were to publish papers, and I do, on conventional themes, on things that everyone is doing, along the same lines that everyone is addressing those topics, my papers are still accepted for publication very easily. But as soon as I deviate from the expected transcript a little bit, let me give you an example. I wrote, as soon as 3i Atlas was discovered, I wrote a paper, and I said, back then it was thought that it's 20 kilometers in diameter based on the reflected sunlight. And I said, if it's that big, then we have a problem, because there isn't enough material in interstellar space to deliver one object like it per 5 years of the survey of that mass. There is just not enough material.
Right. We shouldn't have seen something so big so soon, right?
And I said one possible explanation is either the object is much smaller, or that, in fact, it had a purpose for visiting the inner solar system.
Oh, they don't like that.
And that was in the concluding sentence, just one sentence. So the editor said, I will accept this paper for publication as long as you remove that sentence. So I removed that sentence. Otherwise, the paper will not be published. But I have a preprint version of the paper that was still on the archive. So I wrote, accepted for publication. And then the editor wrote to me and said, you are not allowed to write accepted for publication on the version that you put in the archive that has this last sentence.
Of course.
It's one sentence out of a paper. And I said, well, but it's the same paper. No, if you remove that sentence, you can say accepted for publication. I didn't remove that sentence.
You didn't remove it.
So I have the preprint version with that sentence at the end, and I have the published version without that sentence. Now you ask yourself, in the long scheme of history, does it really matter if I said either the object is very small or it had a purpose visiting the inner solar system? Like, why is that regarded as heresy? Why is that forbidden from the conversation? Obviously, it's something we should contemplate. Turns out the object is 10 times smaller than was originally conceived. So that removes this issue. And I was right. I said either it's much smaller than we think, or it's...
Right.
So this is just an illustration of the level of scrutiny that you go in just adding a sentence that allows for a possibility. Now, if I were to talk about extra dimensions, no problem whatsoever. Do we know that there are extra dimensions? It's just a societal acceptance among the physicists working on it. They say to each other, this is a sandbox that we want to play in, just like kids. Even if it has nothing to do with the reality out there, we just play in this sandbox. And the purpose is to demonstrate that we are smart, that we can do mathematical gymnastics and impress each other, so we can give each other awards. And these string theorists are celebrating in this sandbox. The sandbox is not forbidden. In the same way that the sandbox of allowing interstellar objects to be technological should not be forbidden, but it is forbidden. Why? The public.
The public.
The public. And you would think the public funds science, therefore, as scientists, we have the obligation to attend to the public's interests, right? If there is a question that is of great interest to the public, we should attend to it. And why should we invest $10 billion in the search for microbes while allocating zero funding federally to the search for technological signatures? That makes no sense, given that it's coming from taxpayers' funds.
Because you mentioned string theory, and if we talk about dark matter, dark energy,
we don't know what it is. We invested billions of dollars.
Most people think that we know what that is and that it exists.
We call it dark matter just because we don't know what it is. It's dark, we can't see it, we give it a name. And there were billions of dollars invested in searching for dark matter. For example, the CERN's Large Hadron Collider at the cost of $10 billion was aiming to discover a new symmetry of nature called supersymmetry. And if that were the case, there would be particles associated with this symmetry that could be the dark matter. But didn't find symmetry. Didn't find dark matter. We still don't know what it is. We invested billions of dollars over decades. And unless we invest billions of dollars for the next few decades in searching for technological signatures, we cannot even be on the same, on par with the other unknowns about the universe. And by the way, what I say is often science funds the search for the known unknowns. Like, we know that there should be dark matter, we just don't know what it is. This is a known unknown. However, the most fascinating breakthroughs will come from the unknown unknowns. These are things that even Hollywood scriptwriters cannot imagine. We don't know that we don't know these things. How would we find them if we don't open up the conversation and attend to anomalies, fund risky propositions, even though I think that having another resident in our cosmic street, which has billions of Earth-Sun analogs, is not a very risky proposition. It's common sense to do that. But even if you call it risky, let's put some of our resources in that direction, because every company knows that the next breakthrough, the biggest revenue will come from identifying an opportunity that nobody else identified. It's not part of the traditional thinking. It's something completely new. And they invest in brainstorming sessions. However, in academia, where people are getting tenured to think broadly, everyone is going along the beaten path. And you ask yourself, why is that? It makes no sense. The tenure system was invented to encourage people to think differently. And even Richard Feynman said that thinking outside the box is something that should be encouraged, because he was thinking differently than others. Any innovator, any creator recognizes that we should allow people to go in uncharted territories. The only people that reject that are mediocre people that do not have the imagination, the foresight, or the vision. And unfortunately, they have the power. They could be editors of journals, and then they would say, well, but there is no refereed paper on that subject. Obviously, if you blocked my sentence, how will it be? And you didn't block it because you had a good reason to block it. It's because you don't think it's likely. But who are you to say what the dark matter is? You're not telling the people who write about dark matter that it must be an axion and not... and by the way, the SETI community is also a part of the blame, because they had a committee that decided not to feature any discussions about unidentified anomalous phenomena or technological artifacts near Earth in their conferences. That's an official decision. And I say to myself...
Why would they discount that?
Again, because...
They're still focused just on radio?
Yes.
That's it?
Well,
do you think we're going to find anything with radio telescopes?
Well, Einstein said that if you keep doing the same thing, hoping for a different result, you're not that smart, right?
Right.
The point is that it's a different method. Waiting for a phone call, nobody on your street might call you, okay? However, you might find a package in your mailbox or a tennis ball thrown by a neighbor in your backyard. And that's a completely different approach, because that tennis ball or that package will stay there. All of these interstellar objects that we studied so far are bound by gravity to the Milky Way. They don't leave the Milky Way. They keep accumulating over time. You think of it of space trash, or if they're functional, they might actually visit the inner parts. That was my point, that 3i Atlas could have decided to visit the inner solar system because it was moving within 5 degrees of the planet's orbital plane around the sun.
I wanted to ask you about that. Why is that so strange to come in with the plane of the ecliptic?
Oh, because the chance for that happening at random is 1 in 500. And this is the third interstellar object that we found, only the third one. So you would expect to find hundreds of objects coming at arbitrary angles, just like Oumuamua did, just like Borisov, the second one.
Yep.
However, this one was the third one, and it came right in the plane with a probability of less than 1%. So then the question is why? And one possible reason is to spend a lot of time close to planets and get some information about the solar system.
That makes sense.
Now, this also is an opportunity for us because we have a lot of space assets that can be used to monitor 3i Atlas. And I pointed this out, and Representative Anna Paulina Luna also recommended to NASA to use the Juno spacecraft to look at 3i Atlas. So I find it really paradoxical that people in Washington, D.C., as well as the general public, gets it, while my colleagues do not get it. And, there was a request for a Freedom of Information Act release about whether there are any records within the CIA about 3i Atlas, and the response was, we cannot confirm nor deny
such
I know what records. That means. And they could have said, we don't have any.
But even if it's not alien technology, isn't it worth the investment just to be able to spot these objects?
Yeah.
Because if 3i Atlas hit us, that's the end of everything, yes?
That's right. But you want, for example, to come close to such an object, to image it. Mm-hmm. You want to land on such an object, to collect materials, bringing it back to Earth, would allow us to examine whether the building blocks of life near other stars are the same as on Earth. For us to make a trip to another star, would take at the very least 50,000 years to the nearest star or billions of years to the farther stars in the Milky Way. And that's a very long journey. We are not that patient, right? So these objects already made it to our backyard. It's a lost opportunity for us not to invest more in studying them, bringing materials from them, because observing the universe through telescopes is like observing your street from the windows of your home. It's very different than going there and collecting materials, which would take a long time. But if the material comes to you, if you have objects arriving at your backyard from the cosmic street, you want to study them. You want to put billions of dollars on that instead of, because any mission that would leave the solar system would consume much more money.
Sure.
And you take now, on top of that, there is a chance that one of these is technological, or it could be a Trojan horse. You think it's a comet. From the outside, it looks like a very mundane object, but another civilization decided to take a hike on a passing car and build some infrastructure inside of it that is technological. So if we see any anomalies, we might want to understand what's going on here. By the way, if we wanted to go on a trip to interstellar space, we had the 5 spacecraft that are leaving the solar system, Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, New Horizons. Mm-hmm. These are the 5 over the past half century. But we could also take a capsule full of technological gadgets and collide with an interstellar object like 3I Atlas, bury the capsule inside. You can put, for example, microbes in the capsule, and when the object arrives at another star, it will spray out these microbes, and you will seed life as we know it on other planets.
Does that sound like a good idea?
Well, if it depends. It depends. There are people who love as many kids as possible.
So you don't believe in like the dark forest theory that maybe we should just be quiet?
It's also a possibility. We just don't know. It's possible that the solution to Fermi's paradox is that there are aliens not far from us, but they are quiet, silent, because they live in a dark forest where there could be predators, and those that were not careful were killed. And so they're listening to us, and we might hear from them. And they're not very far away. You can imagine technological craft being parked in the solar system. Any object bigger than a football field will not be visible at distances larger than 10 times the Earth-Sun separation for the telescopes we are operating now. So there could be plenty of technological objects far away, bigger than the biggest rocket we ever built, bigger than Starship, a football field size. Beyond 10 times the Earth-Sun separation, it wouldn't reflect enough sunlight.
This is 10 AU?
Yeah.
Is that what you mean? Okay.
10 AU.
Okay.
And so I did a calculation about 15 years ago where I said, in collaboration with Ed Turner, a colleague of mine from Princeton, I said, what if there are artificial lights in the outer solar system? Okay, would we detect them? So at the time, there was the Hubble Space Telescope, and we asked them, if you take the deepest images of the Hubble Space Telescope, how much light can you detect? And we found that from the distance of Pluto, we would be able to see a city like Tokyo.
Okay, it's still pretty difficult to see.
Yeah, but a city like Tokyo consumes a small fraction of the power supply on Earth,
right?
And there could be some infrastructure. Yeah, it's difficult to see, so it may be there. And the way for you to figure it out, if you were to observe a point of light, is that as this object recedes away from the sun, it gets dimmer faster if it reflects sunlight than if it generates its own light. Another way to look at it, if you have a technological object approaching us, it will get brighter faster than just the reflection of sunlight makes it brighter. That's because the amount of sunlight impinging on its surface declines inversely with distance squared, and then it sends out the reflected light in our direction, and you have another factor of 1 over distance squared. So altogether 1 over distance to the 4th. I had a visitor to my office who discovered most of the Kuiper Belt, many of the Kuiper Belt objects. And I asked him, he's from Caltech, and the minute he sat in my sofa, I said, look, I just wrote this paper that if an object generates its own light, the brightness will increase inversely with distance squared. And if it's reflecting sunlight, it will change inversely with distance to the fourth. Did you ever check if the objects you discovered in the Kuiper belt follow one or the other laws? And he said, why should I check? It must be one with distance to the fourth. That's the answer from the person who discovered many of the Kuiper belt objects.
Why check?
Why check?
Oh, my goodness.
So then you ask yourself, okay, is there any evidence for extraterrestrial technological signatures? And the answer, no, we haven't detected anything. Why? Because we're not trying to detect anything. And when someone suggests that there is an anomaly that we should attend to, we cut it out of the scientific literature.
Did you see anomalies with Atlas as well?
Yeah, so aside from it coming in the plane of the planets around the sun, there was, until it came closest to the sun, there was much more nickel than iron detected around it, meaning that it's anomalous because in all astrophysical objects, you find nickel and iron at similar amounts. They are produced by the same process of exploding stars, supernovae. And this is the first case where you see nickel with no detection of iron. So the only other place where you see it is industrial production of nickel alloys that are used for aerospace applications. So I pointed this out, but the people who wrote the scientific paper reporting about that said, well, maybe the same carbonyl process that is used by our industries to separate iron from nickel operates in nature. So that was in the published literature, eventually the statement made that it's obviously natural, and it illustrates the fact that the carbonyl process used by our industries also happens in nature.
This is very strange. So we have hypothesis A, well, we've never seen that before, so it's false. And then hypothesis B, we've never seen that before, so it's true.
Yes.
Okay.
So that's about the composition. Then there is an anti-tail that was visible from the beginning, opposite to what you find in comets, where the gas and dust are pushed away from the sun. In this case, there is a jet pointing at the sun. And in the most recent, 40 or so images from the Hubble Space Telescope in recent months, I analyzed them with a collaborator, an observer from Italy, and we removed the spherical glow around the nucleus of 3I Atlas, and whatever was left showed 3 mini jets coming from the nucleus, equally separated from each other. So it looks very symmetric, as if these were meant to balance the object. And
this sounds like maneuvering thrusters.
Yeah, it could be thrusters. And I didn't even bother to publish it in the Astrophysical Journal because it will be killed, and why would I waste my time? But I did publish, or submit for publication, the report about the 3 jets without interpretation.
Right.
And the response of the editor was, this is not of interest to the astrophysics community.
But you have images of the jets, yes?
Yeah.
But it's not of interest.
So that was the response. That was the second paper that the same editor blocked without sending it to review. The first one was about the anti-tail. We tried to provide a physical interpretation, explaining the anti-tail. Is it possible with known physics to explain it? We tried to do that. Again, it's not of interest to the astrophysics community. That's what she said.
How did you explain the anti-tail, though? I don't think...
We explained it in that paper. It was in terms of fragments of ice, not dust particles. So there are big chunks of ice that cannot be easily pushed by sunlight backwards, the way you find in comets. We tried to explain in terms of either big particles of dust or ice that are chunks that cannot be pushed easily by the sun, either solar wind or the solar light. But at any event, again, it was blocked by the same editor. And the third time was this report about an interstellar meteor. The editor wrote, it's not of interest to the astrophysics community. At that point, I realized, wait, this journal I submitted in the past, all the papers that I submitted in the past were sent to referees. And I have no issue if a referee thinks, for these scientific reasons, that it shouldn't be discussed, but the editor blocking the refereeing process is a very unusual situation. In 3 months, 3 papers about interstellar objects. And I basically wrote an essay about it, complaining about it. Then 2 months later, the editor sends a review from a referee. And I said, in response, I said, you are gaslighting me. You told us that you don't want to send it to referees. When you saw the backlash from me talking about it publicly, you decided to ask a referee so that you will be covered. And then you send me this report and saying the paper should not be published after you told me that the paper should not be refereed. And it's very easy to find a referee that would be negative, that will be critical.
Well, I mean,
But
because of your exposure, we all learned her name.
Yes.
That was a problem, because now we all know who she is.
Yeah. But my point is, this is not, I don't know her personally. I've never met her. But it's clear that there is a bias here. And it's clear that it's inappropriate, because if she wanted to cover, as she did in the last move, if she wanted to cover herself so that it will not be clear that she is the one expressing the judgment without anyone from the scientific community, she would have sent it to a referee that she knows would be negative, and then she would be covered. That's a very simple way of dealing with that. Instead, 3 times in a row, in 3 months, in the same journal that never does that to my papers. And it just shows you the situation in academia where you may ask, why aren't discoveries being made? Because they are being suppressed by people who have a preferred narrative, which is completely inappropriate. And in my view, the way that corporations, for example, that deal with AI or with the internet, they have teams of people who are brainstorming, okay? And the Nobel Prize was awarded to Deep Mind.
Yep.
So we are in a reality where in academia, thinking boldly is not really encouraged, but even suppressed.
Does the system need to be changed?
I think so. I think the biggest impact is not on me. I don't really care. I have by now, my skin is titanium. I don't get scratched by those remarks.
And people will read your research, whether it's in the journal or not.
But I worry about the young people, because if I were a young person entering the field, I would be very worried about saying something different than the community says, because it would impact my chances of getting tenure.
So if you had a student who was going to publish something that could be controversial, you would advise them not to publish it?
Yes. No, they would immediately see the reality. I had students that published with me on these topics, and they see that and say, that's completely unfair. But the next step is that they move to something far more traditional and work on topics that everyone else knows and then it's very easy to publish, because then you basically say what other people said before with nuances. You don't need, in fact, people forget what happened 5-10 years ago, so you can even repeat a paper that was 10 years ago, repeat exactly the details, but write it in a slightly different way using AI, and you have a new paper that will be accepted quickly for publication. And so they realize that it's a shortcut. But this is their chance for survival. And unfortunately, it's not the most intellectually creative people who are selected by this environment, toxic environment. It's the people who are bowing to authority. And, we know from the past history of science that sometimes you can't bow to authority. And my argument about this subject is it goes beyond that, because in other parts of science, people are not following the narrative of paying attention to experiments. Here, if you pay attention to anomalies, you face a very tough battle to publish. Anomalies are the only way by which we can learn that we're missing something.
Of course.
Yeah, so it's really in conflict with the way science should be done. And I'm trying, I used to be at the paratroopers in my early training in the military. And back then they said, if you see a barbed wire on the ground, sometimes you have to put your body on the barbed wire so that your friends will be able to go across. And sometimes it looks to me like putting my body on the barbed wire so that the young generation will have a better life. But I sort of gave up on changing the opinion of senior members of academia because they're unreasonable.
But the work is still important to continue, yes?
Definitely. I'm doing it, and I'm collaborating with younger people that I have great hopes in discussing this. But at the same time, what would happen if the US government were to disclose some information that bears on this question, are we alone? How would my colleagues respond to that? That to me is the best, a disinfection by shedding light on the evidence, the best way to disinfect the stubbornness of academia.
Well, didn't the government endorse that comet that was found, that they said it was extrasolar, and then the one that with Papua New Guinea?
Oh, yeah. So, in fact, back then I chaired the board on physics and astronomy of the National Academies. My student helped me find this meteor in the NASA catalog that was moving at 60 kilometers per second outside the solar system from 2014. And the reviewer of the paper said, we don't believe the US government. The data must be faulty. And so I reached out through the White House to the US Space Command. But I basically expressed my frustration at dinner of this board on physics and astronomy, and one of the members helped me reach out to the US Space Command, and we ended up with a letter from the US Space Command to NASA stating that at the 99.999% confidence this object is interstellar in origin based on the data that they have access to. So not the published data, but all the data they have access to. Some of it is classified maybe because it comes from satellites that are used to monitor, for example, ballistic missiles right now. So at any event, this letter convinced me to lead an expedition, but it didn't change the opinion of my colleagues. The paper got published based on the letter, but after that, there were other papers written saying, we don't believe the US government, this is not an interstellar object, because the US government makes mistakes. And then they also said, you went to the wrong place. All kinds of arguments. What you found is human-made.
Well, do you want to tell the story about that? Because look, no matter, I followed the story, the spherals and the seismic data. I followed all of that. Even if it turns out that it's not extrasolar, whatever it is, I think it's a very important mission because you've got a Harvard scientist rents a boat, drags a magnet across the Pacific Ocean. That's exciting.
It's very exciting.
That's what makes science fun. It doesn't.
Yeah.
You don't even need to be right. You just need to get people excited about it.
By the way, this was my first expedition. And there were lots of hurdles along the way. I had to get $1.5 million to fund it. I got it. And then I had to bring a team of experts, people that know how to build a sled covered with magnets, put it on the ocean floor. Then I had to worry about whether we bring back anything, because...
Didn't you bring your daughter on this adventure? Did you bring your daughter?
No.
Okay.
I mean, yeah, she was young. Both of them were young. I have 2 daughters.
Yeah, but so what's that like on the boat? Is the crew excited?
I slept on the sofa in the conference room because I was full-time engaged. Every time they would bring the sled back and we had to go, and sometimes it was raining, and basically scrap the magnets for any material collected from the ocean floor. At first, this sled was... basically kiting, just like a kite. It was not touching the floor, and we had some exceptional people on this team that enabled that. And eventually we collected materials, but then I had to worry about bringing the materials back and then finding a very reliable, world-recognized geochemist who happens to be Stein Jacobson at Harvard. He has a full team with state-of-the-art instruments, and I brought it. I had, it was in principle, he could have said, I have no time for your mission. And he agreed to analyze the data, and we published papers talking about chemical composition of some of the material, 10% of it, which is not solar system abundance pattern.
This is beryllium, lanthanum, and uranium. So
uranium.
Why is that unusual, that combination?
Well, it's just, they come at 1,000 times higher abundance, these elements that you just mentioned, compared to solar system materials. And we said, okay, where is it from? We've never seen that before. This is a new composition, never found in any other place.
So tell us about the rebuttal. The rebuttal paper says it's like industrial.
No, so we then checked. So they said it may be coal ash.
Coal ash, that's right.
So we had to go to check the composition, the abundance pattern of coal ash, compared it, and it's not the same.
It's not the same.
By orders of magnitude. And then they said, well, maybe these are tektites. So we checked tektites. And So, you keep doing that, and every time someone wrote a paper, oh, you went to the wrong place because this seismic signal that was detected on Papua New Guinea, it was not related to this meteor. It may have been a truck passing by.
Yes.
And I said, well, we relied on the light emitted from the fireball that was detected by US government satellites, not on the seismometer.
Oh.
The seismometer was just to say there was an event at the same time, like this. But we went back and forth across a region of 10 kilometers in size that was localized by the US government satellite data. Anyway, so
this isn't settled yet. This is an ongoing...
Well, we now are analyzing isotopes, and I hope soon we will have something interesting to
Are you going to go back?
report. Because isotopes cannot be modified, abundances of isotopes cannot be modified by chemical process on the surface of a planet like Earth. If we see an anomaly in the isotope composition, then it's clearly from outside the solar system.
Right, and maybe explain that, because I don't think people understand that all these celestial bodies have their own isotopal signature, yes?
Because isotopes are just elements that have the same number of protons, so they have the same number of electrons in an atom, because electrons balance the protons to make it neutral, the atom. So in terms of the chemical interactions of the atom, all you care about is how many electrons are bound to it, because the chemical interactions are mediated by the electrons, and that reflects the number of protons. But you can add neutrons to the nucleus and they would change nothing in terms of the chemical properties.
Right.
And so isotopes have different number of neutrons for an element that has a certain number of protons in it or electrons. And in order to change the number of neutrons, you really need to put this element through a nuclear furnace, and that requires tens of millions of degrees. That can happen in the centers of stars, but once you produce the elements, they maintain their isotopic ratio from the cloud that made the solar system, for example. And if you bring material from another cloud that was far away, it had a different abundance of isotopes because they came from another exploding star that was not the same, and so you can tell if material is not from the solar system.
Yep.
So anyway, we are now about to release the findings of the isotopic analysis. And of course, these critics, they don't have access to the materials, yet they make a lot of noise. And I don't really care about these people, because we have the materials. We invested a lot of time getting the materials. And I let the laboratory of Stein-Jacobson do its job. Without any intervention, and they, basically following the standard scientific procedure and using the best instruments possible. But in the context of Oumuamua, I wanted to mention one other thing. 3 years later, after Oumuamua was discovered, 3 years later, there was another object that was found by the same telescope in Hawaii. They found it in August 2020, so it was given the name 2020 SO.
Do I know that object? This is not Borisov, no?
No, that is an object from the solar system, it turns out. It's not interstellar.
Okay.
And turns out that object in 2020 was definitely pushed away from the sun by reflecting sunlight. They saw that it deviates from its path, just the way I was discussing Oumuamua, interpreting Oumuamua.
So it can work.
But then they asked, okay, what is this object? You didn't hear about it because there was never a paper written on it. Within a few months, they took a spectrum of the light reflected coming from the object, and they found that it's made of stainless steel.
Wow.
And it was actually, they realized this is the upper stage of a 1966
I remember
launch.
this. I remember this now.
Towards the moon.
Yes.
And so it's definitely technological, and the reason it's pushed by sunlight is because it had thin walls, this enclosure. And we know that it's technological because we produced it. Question is, who produced Oumuamua? Just a proof of principle that this idea works. There was another example of January 2nd, 2025, a year ago. There was the Minor Planet Center that basically catalogs all objects coming close to Earth. They announced a near-Earth asteroid. And they said, we put it in the catalog as one of the near-Earth asteroids. And within a day, they realized that it follows the path of the Tesla Roadster car that was launched by SpaceX.
Oh, no.
So then they said, sorry, we take it out of the catalog. It's not a rock, it's a car. Our mistake, it's a car. We know that it's a car because humanity launched it. Now, just imagine a car like that coming into the solar system would appear as a point of light because it reflects sunlight. And the same organization, the Minor Planet Center, cataloging it, definitely will catalog it as a rock.
It's a strange rock.
It's a strange
It's a
rock.
car-shaped rock.
Yeah, because we were not involved in the launch of this interstellar car. And it's obvious to anyone that looks at these instances that we can be easily misled by conventional thinking about interstellar objects.
It's one of my favorite metaphors that you use is about the people who study the zebra.
Yes.
How does that go?
Yeah, if they are experts on zebras and they see an elephant, they would argue it's a zebra without stripes. And the reason I bring this up is because Oumuamua was catalogued by comet experts. Most recently, just over the past year, they say most likely Oumuamua is a comet without a tail, without any gas around it, a dark comet. This is a comet where you don't see evidence for a tail.
A comet that doesn't look or act like a comet.
Exactly. So I say, I'm just like the kid in Hans Christian Andersen's tale who says, look, I don't see any clothes on this emperor. And the adults in the room are telling the kid, of course, the emperor has clothes. They are just invisible.
Yep.
So I'm happy to be regarded as a kid that tells the truth, or at least what appears to be the truth, based on the evidence.
So are you still convinced Oumuamua was artificial?
I think it's quite possible that it's space trash.
Space trash.
Because, and I'll tell you why. There should have been, given that Oumuamua is 20 times smaller in length than 3i Atlas, that means that its mass is 20 cubed times smaller.
Right.
And, we're talking about maybe 10,000 times smaller than 3i Atlas, okay? So that means that there should be of order 10,000 Oumuamuas for any 3i Atlas that you observe. And the size of 3i Atlas is now based on the latest Hubble Space Telescope data, okay? So we haven't seen 10,000 Oumuamuas. You have, when you look at rocks, there is roughly an equal amount of mass per logarithmic mass interval of a rock in space. So you have roughly the same total mass in rocks that are, let's say, 100 meters in size compared to rocks that are kilometers in size, roughly speaking, or 10 kilometers in size. So there are many fewer objects that are 10 times, there are 10 times less objects that are 10 times more massive. So if Oumuamua is one part in 10,000 of the mass of 3i Atlas, and it could be even less than that, we should have seen 10,000 Oumuamuas before seeing 3i Atlas. We haven't. So what's going on here? I mean, I of course, with the Rubin telescope, we might find many more, and so that would settle the issue.
What about 3i Atlas? Didn't we have some strange, I don't want to say maneuver, but some strange movement of that object?
There is a non-gravitational acceleration, just like with Oumuamua, but it's less significant. The deviation from the path that it would follow if it follows only gravity is tiny. It's every second it's less than the thickness of human hair. Okay, it's really small deviation. But the surprising fact about it is recently, I mean, NASA announces the non-gravitational acceleration. They have their own outlet. And they insisted that the dominant non-gravitational push is away from the sun by a factor of 5 compared to the other components. Then comes along a different analysis, which shows that based on all available data, it looks like the sideways push is comparable to the push away from the sun. And what does it show? Well, first, NASA is not an oracle that is always right. It's sometimes wrong, And second is that, if it were just pockets of ice on the surface of a rock, we would expect the ice pointed at the sun to be heated and therefore the push to be away from the sun because it's the rocket effect that is pushing it the opposite way. We don't see that. We see that being pushed to this. And that could be interpreted. In fact, I'm working on a paper right now in terms of the symmetric structure of 3 mini jets that perhaps are in the same plane, and they stabilize an object in the plane perpendicular to the direction of motion. And then you have the prominent anti-tail that is also contributing. So altogether, you have a system of jets that gives it a push not necessarily related to the direction of the sun.
So you don't like the nitrogen iceberg theory?
Well, that was suggested for Oumuamua in the spirit of dark matter, basically saying nitrogen evaporates as a result of being exposed to sunlight, and therefore, we might not detect it, because usually we see dust or carbon-based gas molecules, but nitrogen would not be visible, so it's a way of making the tail invisible to us. Except that solid nitrogen, even if you use all the solid nitrogen that you can imagine from all stars in the Milky Way galaxy, you run short. There is not enough to produce a large enough population of nitrogen icebergs. And we pointed this out. It's a simple argument on the mass budget. And the author of the nitrogen hypothesis got furious and started attacking me personally in any possible way.
Personally?
Yeah. So, including the expedition, including everything, just because we did a calculation of the mass budget. I mean,
have you paid a personal price or a professional price for speaking out? Like, is it strange with the faculty at Harvard or?
No. I mean, anyone that knows me recognizes that this is the way I do my science. I think of creative ideas often that other people do not think about, and frankly, I'm surprised. Most of the time, someone comes to my office, a student or a postdoc, and tells me what they're doing, and I ask that person, "Did you check this or that?" And they say, "Wow, that's a great idea. I never thought about that." And then they in some cases, they work on it for decades afterwards, and it takes me just a few seconds to hear what they're talking about, to tell them that this would be a worthwhile research area. So it comes to me naturally without much effort. So I think, to me, it sounds like this is common sense. If someone tells me something, I immediately ask them, why didn't you think about this direction? For them, it's like a revelation. And I've never understood that. And I think the reason for that is I think differently. I think from the perspective of the big picture, and I see things that others don't within the practice of science. And so that gives me a sense that, I shouldn't be swayed by what they say, because there were many instances in the past where I suggested something like the microlensing example that we mentioned, and then immediately someone would say, no, it's not interesting, but then they would come back to me and say, yeah, that's interesting. So very often what happens is, if I write an idea like that, it gets posted, someone pays attention to it.
Yes.
That someone develops it and then keeps doing work on it, such that at some point they stop referencing the initiator of the idea. Or if I tell someone at a conference they do it, they don't credit me. And so there are many babies that were born this way without me being recognized as the originator.
It's important, though, because don't you think that even undergrads are just instinctively drawn to the narrative, to the mainstream, that you kind of have to knock them off the path once in a while?
And in a lecture that I gave, a colloquium at Harvard just a week ago, the front row was full of graduate students. They recognized the potential. And even one of the senior members of our faculty came to me afterwards and said, that makes a lot of sense, what you just talked about. I don't understand why people are attacking you. It makes a lot of sense. And I said, yeah, that's my point. And they must be doing that because of either jealousy to the public outreach that I have. And, there are millions of people reading my essays on Medium. I recently...
You publish almost every day. Yeah. On Medium.
Well, it's like a fountain of ideas, and it doesn't take too much effort on my side because creativity keeps pumping new ideas. And now I'm doing better because I jog every morning, so I'm in very good shape, and I eat healthy food and surrounded by women, and I cannot complain about. I'm really happy. I have 2 daughters and a wife, and so everything seems great. But every now and then I get knocked out, and it's often done without the referee noticing. So people are just like this editor trying to do it so that nobody notices. When someone notices, the editor corrects what she does. And so these things do happen that unfairly people are attacking without me noticing, against the rules, so to speak, of academia or professional practice. But I don't care about this, and I'm really in a great place, and I do hope, and I placed a bet against Michael Shermer that by the end of 2030, we might have evidence beyond any doubt that aliens exist, we put some money that will be given to the Galileo Project no matter what, because he believes in the scientific method, the way I advocate for. My advantage relative to him is that I'm practicing it. So I can improve the chances of finding something. He can just comment on it.
Would disclosure from the government qualify you for winning that bet? It would.
It would. And by the way, those people who have well-attended podcasts that are trying to defend science against people like me who are scientific practitioners, I actually publish papers. They don't. These are very strange in my mind because it's just like commentators watching a soccer match, and the commentators can say, "Oh, the way that the goal should be scored is this or that way." But who are they to tell me? I'm a player on the field.
Right.
The one difference from them is that I can actually score the goal. They can just talk about it. For now, they're gaining reputation. A lot of people regard them as astrophysicists, including people like Neil deGrasse Tyson. But he's not a practicing astrophysicist. Just check his record. Bill Maher, check his record. Bill Maher keeps talking about him as an astrophysicist. He is not an astrophysicist because he didn't publish any paper over the past...
He's an entertainer.
Yeah, he's commenting on work that other people do, that is popular within the mainstream. His ambition is to be liked. The best way to be liked is to repeat narratives that you hear, to basically follow the wind, where the wind blows. If the wind will change direction, let's say the government, as a result of Trump's directive, President Trump, the government releases some data that is conclusive beyond any doubt, then Neil deGrasse Tyson will say, yeah, we suspected that. I was talking about this possibility for years, but now we have the evidence. Previously we didn't. Therefore, what I'm doing is right. And, they will these commentators will always follow the popular view, whatever other people are telling him. But they would not pioneer a new understanding of nature. They would not be the ones to communicate the evidence is here because they don't seek the evidence. And the whole point about doing science is the fun of seeking the evidence. It's just like a kid. I feel like a kid in a chocolate store, in a candy store when I'm flooded with data, because that allows me to argue that something is unusual, because at some point when you have so much data, there is no way for dogmatists to brush it under the carpet of traditional thinking. They can't do that. The only reason that they are still doing it because the data is not conclusive enough. So I say, let's seek the data. They say, no, we shouldn't seek that data because the chance of it existing is zero.
Isn't the most important thing in science just to say, I don't know?
Yeah.
They don't like to do that.
So the strange situation that we are living in right now is, on the one hand, practitioners of science are refusing to deal with some questions or to make some statements. Not only that, they will ban talks about these statements in their conference and remove a sentence from the end of a paper that raises a possibility because the data seems a bit strange. Okay, they would remove that. So you have these people. At the same time, you have another community of people making speculations like crazy and not making any prediction that is testable. That is allowed because they are smart people that are doing mathematical gymnastics, but yet their theory is not testable. they would admit that I asked one of them, string theorists, I said, if tomorrow we do this experiment and test your statement, because he made a statement about the universe. I said, so suppose we do observations and we find the universe is not behaving the way you expected. Would that rule out string theory? He said, no, string theory will always be right.
What?
It's my conjecture of what the interpretation of string theory is that might be proven wrong, but it's just one interpretation. So he can immediately shift and continue to work on string theory in a different version of it.
It's unfalsifiable. It's a logic problem.
So my point is, if you have a model that cannot be falsified, what is the difference between that model and a religious cult?
That's a very good point.
But
that's how they treat it. They do treat it like religion.
I remember, when I was younger, the religious community of Orthodox Jews in Brooklyn, the Lubavitchers, believed that the Lubavitcher rabbi will come as a Messiah. Okay? After he dies. So you say that's a theory, right? We can test it, right? So he died. That's a data point. Did he come back as a Messiah? Not yet.
Not yet.
By the way, they built a home for him in Israel, because after the Messiah arrives, should go to Israel.
Yes.
They built a home with the same architecture as his home in Brooklyn, so he would find the toilets easily in Israel. He never came back.
He hasn't.
As of yet. So then you ask those people, you say, okay, well, the data shows that he didn't come back. What do you make of it? Does it rule out your theory? And they say, no, we just have to wait.
Just wait.
So I had the breakfast with a string theorist, and I asked him, what are you most proud about in your scientific career? This guy is in his late 60s. He said, I'm proud of a paper that I wrote about supersymmetry. And I said, but you are aware of the fact that the Large Hadron Collider did not find supersymmetry. Aren't you worried that this is incorrect? And he said, we just have to wait for the next accelerator, because it may be just around the corner with the next accelerator. Now, I ask you, is there a difference between the Lubavitchers and him?
No difference. Didn't you give a talk somewhat recently about the Messiah could be an alien intelligence?
That's another, So one of the reasons that I'm really interested in finding siblings in our family, in the Milky Way galaxy, is because we can learn from them, and they may be more accomplished than we are. And I had a group of religious scholars, theologians, that were led by the current president of the Templeton Foundation, and they came to Harvard, and he asked me to address the question of whether finding extraterrestrials will change religious beliefs. And I said, I don't think so, because I have 2 daughters, and when the second one was born, it didn't take away the love that I have to the first one.
Of course.
So imagining God as being able to attend to one child is very limiting. If you really believe that God is all capable, then there must be many children in our family within the Milky Way galaxy, and we would not lose anything out of that. In fact, if we ever met a more accomplished sibling, the only thing that it can trigger is jealousy, that they reached a higher level. But, we know that siblings have jealousy, but that's not a big deal. It's good to find them, because right now, if you look at textbooks about cosmology, the universe, and I wrote a few of them, they regard the universe as a lonely and cold place, and without any emotional connection to the universe. But imagine that we have siblings out there that we can, in principle, visit, because they visit us. If we visit them, we will learn more about them. I think it will develop an emotional connection to the universe. It will not be lonely and cold the way it is portrayed right now. And that's a huge impact. We would look up at the sky and imagine those other beings being there. And it could inspire us to do better. It's sort of like finding more additional families on your street, that it changes the meaning of your existence. And when you find a partner, I often make the analogy with a dating partner, And of course, we never know if we go on a blind date, whether the dating partner will be friendly or a serial killer, that.
Especially, you've never dated before. Don't give dating advice, Avi.
That's what my wife says. But it
could be something that brings us all together. It's finally something we have in
but
common.
also it can change. I mean, when I found my wife, it changed the meaning of my existence, right? So because your reality is changing, there is now some other intelligent being out there that you can connect with, and that's why I feel very strongly that we should do the search. And then what do you find? The people not only are not allocating funds to the search, but saying we should look for microbes. Now, the one advice I can definitely give on dates is when you go on a date, aim high, don't aim low. Meaning it's much better to meet a partner that is smarter than you are.
I did.
Jen, are you listening?
She is. Probably not. She doesn't watch the show.
Anyway, but what my colleagues are aiming at is microbes. I would be bored with a dating partner that looks like a microbe. Like, okay, we know that there is life out there, and we also know that on dates, the most common partners you would find are mediocre. So, yeah, it's quite likely that there are many more microbes than intelligent beings. But why don't we aim high?
So you're not excited about maybe the Mars showing
I'm pretty confident that Mars, a few billion years ago, had liquid water on the surface because we see the impact of the liquid water on the surface.
Lots of water.
Conditions where it had an atmosphere and it existed for a couple of billion years. And we know that on Earth, a twin planet, life was well developed by the time that Mars lost its atmosphere and liquid water on the surface. So it's extremely likely that Mars had life. In fact, it may have had it before Earth because it's a smaller body and objects cool based on the surface area. And the amount of heat that they have from the formation is proportional to their volume. So if you consider a planet that is smaller, there is more surface area per unit volume, the smaller you make it. So Mars is smaller and must have cooled earlier than Earth. So it may have had life before Earth. And we are talking about difference in hundreds of millions of years. And the last universal common ancestor, it's called Luca, was dated at 4.2 billion years ago. That's the source of all forms of life as we know it on Earth. 4.2 billion years ago is just around the time when life from Mars could have been delivered to Earth by rocks. And if that never happened, Earth could have delivered rocks with life to Mars. So I'm pretty confident there was life on Mars. I don't think it will shock me in any way. Primitive life, for sure. Whether intelligent life developed within 2 billion years, twice as fast as it developed here on Earth, that remains to be seen. One way to find out is to go into these caves on Mars.
Yes.
These lava tubes, put a drone inside of them to search for prehistoric paintings on the walls of these caves.
Wow, that's a great statement. That's. Do you have time for one more segment, Avi?
Oh yeah, definitely.
Let's take a quick break, and I want to come back with just some rapid fire science questions for you.
Yeah, that would be wonderful.
We'll be right back. Back with Avi Loeb. So maybe these are wacky questions, but you're here, and it's I don't get a physicist in here very often.
There are no wacky questions. There are only wacky answers.
Something that bothers me about aliens being here is I can't get my mind around the distances. So you're aware of some theories of Albuquerque's warp drive and all of that. How practical is that? How feasible is that? Can you explain that, how that works?
Yeah, so this is a solution to Albert Einstein's equations of gravity, which regard gravity as curvature of space-time. So the way to think of this, we know the Earth moves around the sun, and we tend to think that there is a force, gravity, connecting the Earth to the sun. However, another way to think of it, which was Einstein's insight, was to think about a marble moving on the surface of a trampoline, the rubber surface, which is curved as a result of putting a heavy object in the middle. And so like a bowling ball, okay, you put in the middle, and then if you give the marble the right speed, it will move on this curved rubber in a circle, just like the Earth moves around the sun. And it's simply because of the curvature of space-time that the Earth is trying to go along a straight line, but the space-time is curved, and therefore it moves in a circle. And if you were to remove the sun, the source of gravity, the Earth would leave the solar system on a straight line. In the same way that if you remove the bowling ball from the trampoline, the marble will continue to move on a straight line on the flat surface of the trampoline. So that's the way Einstein thought about it. Now, you can imagine a solution to Einstein's equations that involves curved space-time. And indeed, there is this solution where it's curved in a very unusual way such that it can propel an object at a constant speed.
So because light speed is the limit, so this is a way around the light speed limit.
As long as you can reach the configuration that this solution embodies, and it requires some form of energy that produces negative gravity, which we don't have. We never engineered it. The universe accelerates, so there is some repulsive gravity acting on the expansion of the universe, but the substance that causes that expansion, dark energy, you would need to somehow engineer it in a different way because it fills uniformly the universe, just as if it's the vacuum energy density. But the question is there any anti-gravity source that we can shape and have quantum gravity engineers design an object like that? The object itself is a solution to a steady state where this object is moving, but we don't know how to produce it and what ingredients you need to put. I mean, you can imagine a cake that is extremely tasty, but you just don't have the ingredients to make that cake, or you don't have the oven to make that cake. So that's the way you should think about it. I can give you another example of a situation where you don't need rocket fuel to propel yourself. Just imagine we had access to a negative mass. All the masses that we know about are positive, and that's why gravity is attractive. But in electromagnetism, we have positive and negative charges. So imagine that just like electromagnetism, we would have negative masses, and they would repel an object close to them. So now I take the negative mass, put next to it a positive mass of the same value, and the total mass of this system would be 0. And that means that if I put it here in the middle of this room, it would float. Gravity will not bring it down. If Newton's apple was made of a negative mass, half of it negative mass, half of it positive mass, the apple would never fall on Newton's head,
Right.
And if I were to make it negative, in principle, next to a negative mass, you can produce repulsive gravity that would propel objects away. Now, the point is, this zero mass object, which with positive and negative, it's like a dipole, that you can just give a nudge and it will escape the pull of the Earth. And just think how much energy we invest in lifting a payload away from the Earth. Most of the size of Starship, the rocket that Elon Musk is working on, the biggest rocket we ever produced, most of the mass of it is the fuel reservoir. And getting rid of that and just taking the payload, putting next to it a payload of negative mass of the same value, and you can just nudge it. A kid, it will just float like a balloon and escape the pull of the Earth. No investment of all these rocket fuel in lifting it out. And such an object, would be an ideal vehicle because you can accelerate or decelerate by pushing the negative mass relative to the positive mass or vice versa. And so the only problem is we don't have access to negative mass. We don't know how to produce it.
Do we have to solve the supersymmetry problem, the hierarchy problem first?
We have to understand how to unify quantum mechanics and gravity. And the most popular idea in this direction is string theory that we discussed, but at the moment they don't make any predictions, not to speak about engineering prospects for doing something with quantum gravity. So we're sort of lost. But if we do detect an object manufactured by another civilization that maneuvers in ways that are very different than rocketry, and accelerates to very high speeds, and perhaps they mastered this technology. So we cannot say that it's impossible. By the way, if we had access to negative mass, we could build a time machine. You could go back.
You're going through my whole list right here.
Okay.
That's great. No, because if you control gravity, you control time. It's the same.
Yeah, you can get back in time. And then the question is, well, if you are to meet your grandparents and convince them not to get married, how can you actually exist?
The grandfather paradox.
Yeah. So most physicists, if you were to ask them, would argue it's not possible because you get into logical inconsistencies. But maybe it's possible with some caveats. Like, any legal document has caveats. So maybe you can never speak to your grandparents in a way that will convince them not to get married, because you won't be able to say that. Or you won't remember. Your brain, the memories depend on the era of time. So maybe you wouldn't be able to design a system that will go back and do a task for you, because as you go back in time, the system would change.
There's a somewhat recent theory about time travel regarding block universe theory, where you can't go back and kill your grandfather because you didn't. Well, how do you know I didn't? Because you're here, so you didn't. So that's kind of solves a paradox.
One way that I phrase it is that no Jewish person had access to a time machine in the future. Why do I know that? Because they would go back in time and kill Hitler.
Sure.
And avoid the loss of 6 million Jews. And the fact that still the history books and all the evidence we have is that Hitler existed means that no Jew had access to a time machine in our future.
Which do you think is more likely, that sort of the block universe, one timeline, or a multiverse?
Okay, so the multiverse I'm really unclear about, because it's talking about what lies beyond the horizon that we can see. Everything that we see in the universe is out to a distance that light traveled since the Big Bang. It's a limited volume. We can't know what's outside of it. And then you have people telling us, out there, the rules would be very different. The conditions might be very different. That's the multiverse. And I say, I just don't know. Obviously, you can spend your life speculating. I don't want to do that. We have a limited time. Let's focus on problems that we can solve within our cosmic horizon. If they were to come, those people that advocate for the multiverse were to come and say, here is an experimental test, that if you do this experiment within our universe, you would know what lies beyond it. Then I would say, great, that's physics. But just talking about, it reminds me of all the promises made to suicide bombers. They can never go back and sue whoever sold them the wrong ideas.
What about regarding multiverse? What do you think is happening with the double slit experiment?
That's a fundamental question about quantum mechanics that we don't fully understand. So the debate goes back to the beginning of quantum mechanics. I visited in August 2025, I attended a conference at the Niels Bohr Institute in Copenhagen. Beautiful place. As I entered the conference room, the auditorium, I realized that it looks familiar, because that's the place where some of the most famous conferences on quantum mechanics were held when Niels Bohr was around. And I sat on the bench, the wooden bench. They told me, you're sitting exactly where Wolfgang Pauli sat 95 years ago. And
Wow.
I said, the only thing I could think when they said that is, this bench is extremely uncomfortable. Because, and I thought to myself, what kind of quality of life did they have back then if they were happy with this bench? Because you can make a much more comfortable chair right now. So why would they sit on this wooden? But apparently they did not have high quality life back then. And those distinguished physicists were sitting on this wooden bench. But I would trade everything I have for going back 95 years, because it was a fun time of realizing something completely new about the physical reality that nobody else knew before. And that is illustrated by the debate between Niels Bohr and Albert Einstein. Albert Einstein thought, it's business as usual. We just need to find some parameters, perhaps, that we are missing that would allow us to forecast how a quantum system behaves. And Niels Bohr said, no, what you see is what you get. This is reality in a completely different way. And in fact, there is no classical physics. It's just an approximation to quantum mechanics, which is the currently adopted view. And Einstein resisted that, and he actually wrote a paper between 1935 and 1940 that argued that quantum mechanics doesn't have spooky action at a distance.
Right.
And he was wrong. The Nobel Prize was awarded. He also was wrong on two other things. He said black holes don't exist, gravitational waves do not exist. Just shows you that people working at the frontiers make mistakes. But those people that corrected Einstein got the Nobel Prize over the past decade in all three issues. So coming back, Niels Bohr was right, but we still don't understand. Most of those decades of physics confirmed quantum mechanics to exquisite precision, meaning we can calculate things, but we don't understand. And it brought the phrase, shut up and calculate. Like if you ask too many questions, just like you tell a kid, don't ask so many questions, just use this as a way to predict things, and you will get agreement with experiments, which has been true, but there is something we're missing. Now, I wouldn't be surprised if what we're missing has to do with gravity, that because we have quantum mechanics without gravity, we have this distorted view about how quantum mechanics operates, and we don't fully understand it. A system can be very big, and if you do something to part of the quantum system, the other part knows immediately, faster than light.
Yep.
And so that's the spooky action at a distance, and quantum entanglement is derived from that. And we don't understand it perhaps because we don't have quantum gravity understanding. And once we figure out what is missing, perhaps we'll have a full quantum gravity theory. So it may have nothing to do with extra dimensions, the way string theory operates. I don't know what it is, but if I had to guess, I would say it must be something that we are missing that perhaps has to do with the way gravity operates combined with quantum mechanics, which we don't know how to marry these two things, as of now.
Could it be a graviton carrying that information from?
Well, that's part of the so-called semi-classical picture that we have of gravitational waves as a collection of gravitons. We've never detected a particle of gravity, a graviton, on its own, like a single particle, like we detect a single photon and a particle of light. And so we can talk about gravitons, but it doesn't give us a quantum theory of gravity. It's just a phenomenological way of approaching in a semi-classical way how to describe gravity. But there are other derivatives that are done in this way. And for example, Stephen Hawking decided at some point to prove a graduate student at Princeton wrong. The graduate student's name is Jacob Bekenstein back in 1970. He said, Hawking showed that if you take two black holes, you can associate a surface area around them. That's the event horizon. Mm-hmm. Whatever gets inside cannot live. It's the ultimate prison. It's just like Las Vegas. What happens there stays there.
Right.
And Hawking showed that if you take two black holes and combine them, merge them to make a bigger black hole, the surface area can only increase. So Bekenstein said, as a student, he said, that reminds me of the second law of thermodynamics, because maybe the entropy of the black hole is proportional to its area. So then entropy always increases, and that will explain it. And his mentor, his advisor, was John Wheeler at Princeton. He said, this is such a crazy idea that it may be right. And Stephen Hawking heard him speak at a conference, and he said, that's complete nonsense. So he wanted to prove him wrong, Jacob Bekenstein's wrong, and worked on the problem and did a semi-classical calculation and showed that the vacuum near a black hole is indeed different from the vacuum far away, so that there is thermal radiation coming out from the distorted space-time near the horizon of a black hole. And basically demonstrated that Bekenstein was correct. There is entropy there. There is a thermal radiation. There is a temperature to black holes. They radiate. This is called Hawking temperature, Hawking radiation. It's his biggest accomplishment that resulted from him trying to prove wrong Bekenstein. And what this demonstrates is how in science, if you are confident that something else is wrong, try and prove it, okay, and argue with it, because you might realize that you are wrong. And that's the way good science is done. And actually, Hawking got his fame out of this attempt to disprove Bekenstein, and it's called the Bekenstein-Hawking entropy.
If that entropy, so that's been proven, that's there.
No, we didn't detect it, but we expect it to be there. There are big issues because the radiation comes out as thermal radiation with very little information in it, just the temperature.
Because it's ignoring gravity, isn't it?
Well, the curvature of space-time is the origin of this radiation next to the horizon. And the problem is if you throw an encyclopedia into the black hole, and then the only thing you get out is thermal radiation that is characterized just by the temperature as a function of time. And eventually the black hole shrinks and loses all of its mass to this radiation, and it's basically an explosion. But it takes a long time for the astrophysical black holes. If we had tiny black holes, the mass of asteroids, they would evaporate within the age of the universe. We haven't seen any because maybe they were never produced in the universe, small ones. But the point is, it creates a new headache for theoretical physicists, because where did the information go to if the black hole evaporates and we dumped information into it? Is it recorded somewhere in the radiation or not? And that's still being debated. It's an unsolved problem, even with people that use string theory. And so we don't know if Hawking radiation exists because we haven't detected primordial black holes that are small enough to create it. We haven't seen it.
Does the math allow for it?
Yeah.
It does. This was your area of expertise, wasn't it?
Well,
black holes?
You could imagine the early universe having inhomogeneities, meaning some regions that are much denser than average, instead of expanding with the rest of the universe, collapsing to a black hole. And back then, in the fraction of a second after the Big Bang, those black holes would have the mass of an asteroid or smaller than that, the mass of a dust particle, down to that. The smallest black hole we can imagine has a mass of 10 to the power minus 5 of a gram. That's called the Planck mass, the smallest, because what happens for those black holes, their size, the horizon size is equal to the wavelength of the radiation emitted by them. So it's sort of an object, the smallest black hole you can imagine, because it will immediately evaporate. But if the universe had dense regions that collapse to make black holes, this could be the dark matter, as long as they don't evaporate. For them not to evaporate within the age of the universe, they need to be more massive than a kilometer-sized asteroid. Okay, and so about 10 to the 15 grams and higher would not evaporate. It's a viable dark matter candidate. It was ruled out by microlensing experiments, the method that I helped develop. They were ruled out down to the mass of the moon or so, or even smaller. So basically, the allowed range for dark matter, being primordial black holes that do not evaporate, is in the mass range of asteroids right now, and we don't know. It's possible the dark matter is these primordial black holes. If there were smaller ones, we would see them exploding, and we would see photons coming out of them, and we haven't so far.
When they explode or evaporate, do we get all that potential energy released, that information?
It's like an explosive process, because the smaller the black hole is, the shorter is the evaporation time. So if you start this process going within the age of the universe, it will accelerate over time, and you will end up in an explosion. So Hawking's paper was called Black Hole Explosions. So we don't know if that happens in nature, because there still are some theoretical problems with the information paradox. And maybe the way quantum gravity should be formulated somehow avoids Hawking radiation. We don't know.
Science fiction writers like using singularities as a power source.
Well, I advise to some colleagues that work on string theory to test their theories by entering the nearest black hole, taking a journey there. And one of them said, when I suggested that I have an ulterior motive for sending them there.
Yes, you do. What would it look like someone entering the event horizon, what would that look like to the observer watching that?
You would see everything from the universe outside the horizon because it enters through.
Right.
But you wouldn't be able to transmit, to send a DM, a direct message to your friends. By the way, I asked once students at Harvard in my class, I said, if a spacecraft landed at Harvard Square and you were invited in for a one-way trip, would you take it? My answer is definitely yes. I'm so frustrated with what we're doing here on Earth that any trip beyond Earth would be worthwhile.
I don't know if your wife would agree, but...
A decade ago, she said, just make sure that you leave the car keys with me. And also that they don't ruin the loan when they lift off and take you out there. But recently, just several months ago, I asked her again, and she said, I will join you. So first, this is testimony that our marriage is okay so far, that now she wants to join me. But the truth is that she's so frustrated by reading the daily news with what we are doing here on Earth that she gets my point. And so I definitely would go on such a trip. But the students told me something that I've never expected. They said, we will only go on board this spacecraft if we can use Instagram to share with our friends on Earth. And I asked them, wait a minute, why would you care about your friends, the ones that you live on Earth? Because you would never see them again.
Right. Millennials, they still care.
It just shows you that their priorities are not right. Like, if I were to climb the Himalayas, the tallest mountain, I would care less about what other people see. I would just enjoy the experience. And I was also asked in a 90-minute interview by Natasha Zuves at News Nation, it should air very soon. She said, I'm really worried about these aliens. You know, they could be dangerous. And she asked if I lose sleep. And I said, no. And she said, well, if you were to know that you will die when you encounter them, would you still want to meet them? And I said, sure. Because just that knowledge by itself, the experience itself is a thrilling experience. And I would much rather go through it and die than have a long life listening to news broadcasts or News Nation. You know, like, these are very depressing. I listen to, what's the point about having a dull life, long life that is dull compared to a short life that is exciting?
So what do you think we're seeing in the skies? They seem to be operating their own micro-universe, these objects that can...
I don't know. I want to get as much data as possible. If the government has it, I would love to help them figure it out. So at the moment, within the Galileo Project, we're looking for unusual objects. And once we record them, obviously I'll try to make sense of them. And if the US government has that kind of data, then I'm happy to help them. So we shall see. I hope that in the coming months and years, we'll know much more. I hope there is something out there. And, you know, if you adopt the mindset that, where is everybody? I have no partner out there. You will never seek a partner. You will never find it. So I prefer to be an optimist, because sometimes life is a self-fulfilling prophecy. If you tell yourself, there is someone waiting for me out there, you might find that someone. If you say that's heresy and that possibility should not be contemplated even in a single sentence in a published paper, then you will stay alone. And of course, you will maintain your ignorance forever. That's not the future that I would like to be part of, where we remain ignorant because that's what we prefer to believe.
Are there any other scientists doing good work that you would recommend that maybe don't get quite the publicity that you do?
There are scientists that are either attending to reports by other people, or they are going to very short trips to collect some data, but they're not conducting a systematic scientific study the way that the Galileo Project is doing. And of course, there are lots of people who are speculating and talking about the subject. And it's all about evidence, you see, that a picture is worth 1,000 words. I would prefer not to speak at all. Just if I had it in my hand, the proof, then I would just show it and let's move on. Like, why do we have to talk about it? And a lot of people just have an opinion. It's not bad as long as you're motivated to collect evidence and show it publicly.
What would you do if someone just dropped a piece of a craft on your desk? What would be the first thing you do with it?
I would check it. I would check the isotopes. I would immediately be able to say whether it came from outside the solar system. In fact, there were people wanting me to look over pieces, but they never delivered it.
There are some pieces floating around out there. I don't know how real it is, about recovered metal from craft that's arranged, sort of layered in a lattice structure. There could be a waveguide.
Right. So, but the publicly available data is not conclusive. And that's what I would like to find. Something that is beyond any reasonable doubt, that you can present to a reasonable person that is not a member of academia, and they will apply common sense, and it would be obvious that this is the right interpretation.
Avi, you're so hesitant. I don't know why you get attacked so much. You're so hesitant. You're so careful. When I read about particles winking in and out of existence, it makes me think about zero-point energy. Mm-hmm. How do you feel about that? Is that real?
Yeah, that's definitely something in the context of physics. That basically means that the vacuum itself, if you empty space of all the material and radiation in it, there is something left. Now, whatever is left, the vacuum, has no observable consequence if it's uniform throughout space and time. If it's the same value everywhere, the only reason we feel forces is because there are differences between the vacuum at one point and another point, or any entity at one point exerts some force when the concentration of that entity is different at different locations. And so we wouldn't expect to discover the 0 point unless we consider gravity. Because in the case of gravity, if there is some energy to the vacuum per unit volume, that generates a gravitational force. In fact, that is the force that appears to push the galaxies apart in the present-day universe. It's triggering the acceleration of the expansion. The expansion is not at a constant speed, or it's not decelerating. You would expect, if there was positive mass everywhere, matter and radiation, that the universe would decelerate, would slow down its expansion as a function of time. But what we are seeing now over the past half of cosmic history is that the universe accelerated its expansion. And if you extrapolate that to the future, every galaxy away from our own galaxy, the Milky Way, will be moving faster and faster as time goes on, eventually exceeding the speed of light. So if you had a friend that was sending you text messages from another galaxy far away, eventually these messages will not make it. They will not be able to bridge the gap that is open between you and the friend, because the friend is accelerating from you faster than light.
Right.
One way to think about it is an expanding balloon that has ants on the surface. So the ants walk at some speed, just like the speed of light for photons. They propagate at some speed. The ants can walk and visit the entire balloon as long as the balloon is not expanding too fast. If you expand the balloon very fast, if you blow it up quickly, the ants would not be able to visit the entire balloon. They would be limited to a small region, and less of it as it expands. And so that's the analogy, that if space itself is expanding in an accelerated fashion in the universe, then photons, particles of light, will not be able to bridge the gap being opened between two different points on the surface of the balloon. So as a result, we remain isolated. And if you have a friend in another galaxy far away, you would be able to know about their whereabouts only up to a certain time in the future. Once they reach the speed of light, you won't be able to know what's happening there. It's sort of like the horizon of a black hole. If your friend gets into a black hole, you don't know what happens after that. And the only image you get is when the friend crossed the horizon. And it's sort of like the final picture at the ending of a Western movie, where the cowboy waves his hand and the image freezes.
Right.
That's what you would see if a friend falls into a black hole, or if a friend is in another galaxy in an accelerating universe. And we will be left in the dark, in empty space. The only thing available to us is whatever is within the region around the Milky Way galaxy that is bound gravitationally and doesn't participate in the expansion. So all the stars that we see in the Milky Way will still be here. And but in other galaxies, we won't be able to see them anymore in the distant future.
Wouldn't time be slowing down as well?
No, time keeps progressing. It's just that the space is expanding.
I mean, as they reach the speed of light.
The translation between the time in the frame of those friends and in your frame breaks down, because you can't actually learn about what happens to them, just like when someone enters a black hole. So it's a fascinating concept. You might say, oh, there wouldn't be any stars left. No, actually, the most common stars are about 1/10 of the mass of the sun, and they can live up to 10 trillion years, 1,000 times longer than the current age of the universe.
I didn't know they can live that long.
Yeah, so one very fundamental question that I wrote a paper about a decade ago, I said, well, these stars that are most common, 1/10 of the mass of the sun, they live 1,000 times longer, and they're very common. So why don't we live next to a low-mass star like that, a dwarf star, in the future? There is much more opportunity, right? In the future, around such stars, in the habitable zone around them, we do see planets. In fact, the nearest star to us is Proxima Centauri. Mm-hmm. Its habitable zone is 20 times closer to the star because it's a faint star. And there is a planet there, Proxima B.
Yep.
So why aren't we on a planet like that in the future? Because that's the most typical thing you would find. The answer is probably these dwarf stars, because they're fainter and they live longer. You have to get close to the furnace when the furnace is very dim. Okay, so the habitable zone is close in. And then you are vulnerable to the wind coming from the star or to any flares on the surface of the star.
Right.
And that could rip apart, dislodge the atmosphere of the planet, so you won't have life as we know it on a planet in the habitable zone around the most common dwarf star. That explains why we live next to a star like the sun, where we can be comfortably far away from it so that it doesn't damage the prospects of Earth retaining its atmosphere. I mean, Mars lost its atmosphere. We have a reminder next to us that it can happen. You can lose the atmosphere. We don't understand exactly why Mars lost its atmosphere.
It wasn't a core issue?
It may have had to do with the lack of magnetic field keeping the atmosphere bound. It may have been a solar flare, as Mars is a smaller body and the Earth is more robust in that sense. So my point is, we should feel that it's a blessing to be here on Earth next to a star that is in the middle of its life, and within 1 billion years would be too bright to allow for liquid water on the surface of Earth. For now, let's enjoy the party while it's lasting. But at the same time, let's recognize the fact that we need to leave Earth in order to survive in the long term. So if we want to build any monuments that will be remembered by historians of the Milky Way galaxy, nobody would mourn humanity if we were extinguished tomorrow as a result of World War III with atomic weapons, or as a result of climate change, or as a result of something like AI taking over, whatever scenario you have in mind. There is nobody out there that would say, oh, too bad, humanity, that was fun to have around. We will just die and that would be it. And there were lots of civilizations like ours that perished, probably. And those tragedies are not remembered. The only way for us to be remembered in the long term is to leave Earth on a space platform that carries humans in a comfortable environment. We started in the jungles of Africa, and like 100,000 years later, we live in high rises in cities. So in the jungle, we had to fight for resources. If we get a banana, then someone else cannot have it. Now we can call DoorDash or whoever, get it to your front door. And that, is a huge transformation that humans were able to make. I argue that going to space is less of a leap because it will still be technological, but instead of being in a high rise, it would be in a spacecraft. But you need to generate artificial gravity. That's a huge investment. I don't think going to Mars is necessarily the ambition that we should have.
That doesn't excite you.
No, it's just another rock,
Right.
and it's even worse than our.
Right, it's
so
worse.
Just thinking, it's not comfortable right now. It's a desert without air, without an atmosphere, no liquid water on the surface. Just think about if we were still with the chimpanzees in the jungle, and someone would look out and say, "Oh, we use the bananas on this tree, but in fact there is another group of trees that we can get, but they have less bananas. Let's go there." I mean,
That's a good point.
that's Elon Musk.
So where do you go? Enceladus, Europa?
No, I say we build a space platform. Now, you may say, well, that's a lot of money, but,
Well, what do you do? Unlimited resources. What do you build?
So we invest $2.4 trillion a year on military budgets. I say, if we decide it's a priority because we saw a spacecraft from another civilization or just because we see the light, we allocate $1 trillion a year. I think within this century, we will put the best architects, the best physicists, and the best engineers on this project. We will be able to design a space platform that is the size of a city, okay? Roughly the size of 3I Atlas.
Right.
Kilometers in size. And generate conditions that are comfortable for humans, for many generations of humans. And maybe by then we will also solve the aging issue, so that there could be humans that live throughout the journey, but it's just a matter of priorities, and it will be the Manhattan Project on steroids. But it will reflect an important insight into the future of humanity that is better than investing the same amount of money. It's not like the money is not there. The money is there. We invest it in either trying to kill other people or prevent other people from killing us. That's what we are doing, putting the trillions of dollars every year to that purpose. I'm saying we can still keep doing that if you enjoy the mud wrestling.
They enjoy it.
Yeah, you can still do that, but let's allocate $1 trillion out of the 2.4 to space exploration, and just think about the new technologies that we would develop. And I call it Noah's spaceship in my book Interstellar. It's sort of like the ark that Noah built to save life from the great flood, and in this case, saving humanity's future. With a space platform that can accommodate humans. And of course, if we see someone else did that, then it will inspire us. But this kind of monument of things that we send to interstellar space that would survive for billions of years is the only thing that will be remembered by whoever writes the history books of the Milky Way galaxy in the long-term future. Here on Earth, I'm sure that within a few decades, the history books will be written by AI.
Yes, they will.
And so we obviously need to be kind to them so that they don't say bad things about humans in the future. But if we venture to space, that could be a place where we can deliver the vision that we have, to a much bigger community, perhaps, of other beings. And I find that exciting. I see that as a messianic age, because if we see a space platform that was developed by another civilization, it will perhaps inspire us to cooperate, to live more peacefully with each other, because we are all in the same boat, and this boat is about to sink in 1 billion years, no matter what we do. So we better cooperate and build something else that carries us away from this sinking boat. And that is the messianic, era that is talked about in religions of peace and prosperity and cooperation. And I just think that the Messiah will not be a human.
Here we go.
It might be from another star, that's all. Because it will inspire us to do. We could reach the same conclusions on our own, but
sure.
I'm not naive to think that policymakers will change the allocation of $2.4 trillion a year to military conflicts just because we could go to space.
So you've got your ship. Do you know where to point it yet? Because I think you just get one shot, right? You got to get it right.
Or you can send a few of those. But I think if you allow it to maneuver, you don't need to decide at the beginning of the journey where to go. It will be sort of like a survey similar, to explorers over the centuries that found new lands.
Send a scout.
Yeah, not because they knew about those territories. You can call it the promised land. It took the Jewish people after left Egypt 40 years. That's because they didn't have navigation system. They didn't have GPS.
Right.
So instead of giving them the 10 commandments, they would have been much better off having a GPS system.
They did have an ark that helped.
Yeah, the question is, what was it?
Right.
But if I were to give them a gift, I mean, obviously there was a reason for the 40 years they spent in the desert, which was for the older generation that adored materialistic things, which, if you look at our culture right now, this is pretty much where we are.
Yes, it is.
They wanted this desert generation to go away, and it took 40 years. So, maybe we'll go through a similar transformation. We need 40 years for the materialistic approach to fade away. But I do think that if we send towards some promised land, if we send spacecraft, and we don't need to know that in advance, we can just visit places and then figure out where is the best place to go to. And once we realize that, we can send self-replicating probes to all these places that share the same qualities and hope that, just like in biology, the dandelion flower sends its seeds in the wind.
Right.
Some of them land on fertile ground, some not. And, dandelion flowers are still around. And it was a successful strategy for nature to send the DNA in those directions that the wind takes them. And we can do the same thing and send a lot of seeds in many different directions and sort of play the role of an interstellar gardener.
This is why I hope they're working on gravity and solving that problem, because if you create that drive,
yes,
then you don't need a generational ship. You can just, we'll see what's over here. That wasn't great. Let's see what's over here.
Right. When you say they, do you mean aliens or government?
I meant scientists, but it's probably the government.
Well, if other, extraterrestrial scientists did it already, then we can get a shortcut. It would feel like cheating in an exam where you look over the shoulder of a person next to you and get the answer. But
are you saying they don't cheat in Harvard?
I didn't say that. Now there is a big issue about grading because everyone gets an A, at Harvard.
Oh, yeah. And that endowment's important.
Well, but then how do you reward exceptional students? The
Totally
point
agree.
is it's just unjust. And so one way is, of course, to put a cap on the fraction of students that get an A, which is being proposed. But another that I think is better is to force the median grade to be somewhere that is not A, like B plus or something.
I grew up on the curve back in my day.
Yeah, exactly.
Last question, Avi. Should we be changing what we're looking for when these interstellar objects come in? Because apparently they're going to come in more frequently than we thought. Should we be changing what we're looking for?
Definitely. It may be a time-dependent question because, in particular, if the visits reflect what we are doing, if they are not far and they recognize, it would have taken 3i Atlas just about 80 years to arrive at us from a distance that is 100 times the Earth-Sun separation, the Kuiper Belt. And it would have taken 8,000 years for it to traverse the entire solar system all the way out to the edge of the Oort cloud. So
the Oort cloud goes that far out, huh?
100,000 times the Earth-Sun separation.
My goodness.
And it's mostly empty space, and we don't know what's out there. The only reason we know it exists is because rocks, icebergs, every now and then are being sent into a trajectory, a path that comes close to the sun. And these icebergs basically appear as comets. These are long-period comets. So we know that they come from far away and that are very loosely bound to the sun. But every now and then they dive in because of perturbations by Jupiter, for example.
Have you heard the theory that there's a planet X out there that could be throwing rocks this way?
Yeah, we, as I say, even planets 5 times larger, this is planet X, 5 times larger than the mass of Earth out there are very difficult to detect. And so...
Because Oort cloud is still theoretical except for the few objects, yes?
Well, what we see are the long-period comets that originate from icebergs being sent closer to the sun. And as a result, we recognize there is a whole population out there. But we have never seen them at those distances because they don't reflect much sunlight. They move very slowly at a speed that is 1,000 times slower than the speed of the sun of the Earth around the sun. So
1,000 years.
No, because the orbital time is not just the speed. If they move on a circle, they are also farther away, 100,000 times farther away.
Oh, wow.
So you take 100,000, times 1,000. That gives you a very long period. If there is a circular orbit at the edge of the Oort cloud of 100 million years or so. These are old objects, and some of them are being exchanged with passing stars, presumably. So some of these objects might have been interstellar, came from another star that passed by, because the distance to the nearest star is twice the outer edge of the Oort cloud. So it means that if the nearest star has an Oort cloud around it, these are just like billiard balls that are touching each other, and space is packed with those. You would expect most of interstellar objects to originate from the edge of the Oort clouds, because they can easily be dislodged from. They're not bound by, they're not deep in the potential well of a star. They're sort of loosely bound, and they can easily get kicked out. And that's why it was surprised. So you would expect all of the interstellar objects to be comets, the way that the long period comets are. Yet, we saw Oumuamua without a cometary tail, the first recognized interstellar object. So that's another surprising fact about it, that it wasn't a comet. And who knows, what is in the solar system, right? By the way, within the orbit of the Earth around the sun, there are about 35 million objects that are roughly the size of a person from interstellar space. And we can't see them because they don't reflect enough sunlight. So there is a huge reservoir of interstellar rocks that we are not aware of. And once every few years, one of them collides with Earth, one of those meter-size rocks. But what I'm trying to say is that the information we have is very limited. For example, even with the Rubin Observatory, state-of-the-art, if an object were to move 10 times faster than the rocks of the solar system or the planets of the solar system, which are moving at tens of kilometers per second, if you had an object moving at hundreds of kilometers per second, it would spend very little time in each snapshot of the sky that we take with those telescopes. It would appear as a streak.
Right.
300 kilometers per second, 10 times more than Earth's speed around the sun, is just 0.1% of the speed of light. 3 orders of magnitude smaller than the speed of light. So there is a huge range of velocities that are larger than our rockets that we would miss if objects were moving in our backyard very fast. Just think about your own backyard, and if someone passes through very quickly, you wouldn't even notice that. And that's the situation that we're in. In addition to the fact that small objects are not recognized, objects of the size of Voyager or most of the space objects that we launched are not being detected, and they could be all around us.
What would you have put on Voyager's golden record?
Oh, I would never put music from the 60s. In fact, I think it's a sign of arrogance to imagine that the aliens care much about us, because if they ever find it, they are far more advanced, and it's just like, it's really ridiculous for humanity to brag about our accomplishments.
The Beatles are 3 chords. That's all it is. Nothing to it.
There is an image of a man and a woman, and as if they care much about it. I would much rather send, some spacecraft to learn about them, because it's most likely, it's just like Darwin's principle of the fittest survives, for natural selection. Obviously, there are lots of mediocre aliens out there, and many of them live on trees, in jungles, and, they didn't make it yet to technology. And in order for us to meet them, we have to visit their place and start sorting through the trees. That's a lot of work. It takes a long time to go from planet to planet and search the bushes and the trees. And on the other hand, you can just stay where you are and wait for someone to reach you. These are the most accomplished ones. These are the ones we want to imitate. These are the dating partners that we can meet if we aim high rather than low, and without any effort. So
these are the ones scoring on the curve. These are the ones getting the real A's.
These are the ones that are at the top of the food chain, not us. And we should learn from them. And it would inspire us. And maybe they don't exist, but let's first invest the billions of dollars in searching for them before concluding anything. In my view, this would be the most inspiring discovery. And I have a lot of artists that are approaching me. They appreciate it. I got 2 bronze sculptures of Galileo Galilei from Greg Wyatt, the sculptor, and 51 watercolors from him were donated to my office. So my office is now a mini museum. I then got from an artist in Florida, Peter Tooney, I got a huge piece of art that is bigger than my body. I had to carry it to my office, which basically says, history awaits. He was inspired by the kind of research I'm doing. There was a musician, a songwriter from the UK, Ollie Swan, that his manager, producer, sent me his song, and
Aliens Are Real.
Aliens Are Real, and I played it in my lecture actually at Harvard a week ago.
That's where I heard it.
Yeah, and they asked me for an endorsement, but it's the greatest reward is to see all these. And there was a children's book about aliens sent to me from Brazil, where a class did that. There was also a book of poems that were sent to me by Alan Wagstaff, a poet from New Zealand. And so I feel that the artists are inspired. There was also a new painting that I received just a few days ago by an artist, and she said, her last name is Denning, and she said the title of this piece is it's a freaking spacecraft.
I'm glad that you're featuring the artists, because as important scientists are to our society, I think artists are equally as important to creativity and energy.
Yeah, they are definitely. But the biggest reward I get is from parents writing to me, and I got hundreds of those, that their kids decide to pursue science after hearing me on television. That's, to me, is the biggest blessing of my appearances, because I gave up on my senior colleagues changing their minds. And my hope is that the young generation of fledgling scientists will be open-minded and will actually discover all the things that my generation missed.
I think that's a great place to leave things, unless there's anything you wanted to add, Avi.
No, I think we could have talked for hours.
I certainly could have a whole list. So we need to let people know about the Galileo Project, donations wanted. Also, your YouTube channel, we have to get subscribers on there so you can get all the AI imitators out.
Right.
I was telling you earlier, I was telling Avi that I was listening to just some of his lectures, getting ready for this conversation. And I heard him talking out of the corner of my ear about how Atlas was maneuvering through and I went, whoa, hold on, I didn't hear that. But it was just an AI, Avi. So we need to get rid of those.
Exactly. That's my mission right now.
Okay. Anywhere else to find you? Your Medium page?
My Medium page for updates every day or so. And I have another book coming out on the expedition, hopefully within a year, with MIT Press. My previous books might also be of interest. Extraterrestrial, which became a bestseller, and also Interstellar, which is what we were talking about today.
Both very good. And I hope when that book comes out, you'll come back and see us.
I would be delighted.
Professor Dr. Avi Loeb, thank you so much. It's been a treat.
Thanks for having me.
Bye, everybody.
All right, so that's Avi Loeb. And I got to be honest, I really enjoyed that conversation. He's not what you'd expect from a Harvard professor. There's no ego about him. The guy was offered a spot in Israeli special forces and said, no, I'd rather think. And that kind of tells you everything. So here's what we can verify. Avi Loeb is the real deal. Frank B. Baird Jr., professor of science at Harvard, chaired the astronomy department for 9 years, over 1,000 published papers. He was selected for the Talpi program, Israel's most elite military science unit, at age 18. He got a fellowship at the Institute for Advanced Study at Princeton, where Einstein worked. He's tenured at Harvard in under 3 years, where the average is 7. So these aren't claims, these are public record. But the big stuff. Oumuamua. In 2017, the first detected interstellar object showed no cometary tail, no visible outgassing, and yet it accelerated away from the sun. Avi proposed it could be a light sail, a thin, flat object pushed by solar radiation. His critics called it a dark comet, a comet with no tail, no gas, that doesn't behave like a comet. And he makes a fair point. At what point is a comet that acts nothing like a comet just not a comet? Then there's the Pacific expedition. In 2023, his team dragged magnets across the ocean floor near Papua New Guinea to recover material from IM1. That's the first recognized interstellar meteor, which was confirmed by US DoD data. They found spherules with a composition never seen in solar system materials: beryllium, lanthanum, and uranium at 1,000 times the expected abundance. Now, critics from institutions like the University of Chicago published a rebuttal arguing it matched coal ash. Avi's team compared the profiles and says the match doesn't hold. The isotope analysis is still underway and could be definitive. Avi brought up something I hadn't considered, though. There's a company called Reflect Orbital applying to the FCC right now, as in right now, to put 50,000 mirrors in orbit to beam sunlight down to Earth at night. Now, it sounds like a good idea until you realize it would blind every telescope on the planet. We wouldn't be able to see near-Earth objects coming. And he framed it as a potential new answer to the Fermi paradox. Maybe civilizations just blind themselves before they ever see the asteroid that eventually kills them. That's kind of scary. Now, I don't know if Oumuamua was a light sail. It probably wasn't. I don't know if the spherules from the Pacific are extrasolar. They probably aren't. But I do know this. Avi Loeb is the only scientist at this level who's actually going out and looking. He's not commenting from the sidelines. He built the telescopes. He rented the boat. He's dragging magnets. And if you watch my episode on panspermia, We Are the Aliens, a lot of what Avi talks about regarding life traveling between planets connects directly to that episode. Same with the episode, The Greys Are Future Humans. Avi even floated that idea himself, that if aliens look human, they might just be us from the future. You can follow Avi's work on his Medium page where he publishes almost every day. His books, Extraterrestrial and Interstellar, are both worth reading. And if you want to support the Galileo Project, they take donations at the project website. He's got a new book coming out with MIT Press on the Pacific expedition. That should be interesting. Now, whether he's right or wrong, science needs more people willing to put their reputations on the line in pursuit of something important. And I think Avi Loeb is one of those people. But I leave it up to you to decide. Until next time, be safe, be kind, and know that you are appreciated.
In Area 51, a secret code inside the Bible said I would. I love my UFOs and paranormal fun, as well as music, so I'm singing it like I should. But then another conspiracy theory becomes the truth, my friends, and it never ends. No, it never ends. I feel the crap cat and got stuck inside Mel's hole with MK Ultra. I'm being only too aware. Did Stanley Kubrick fake the moon landing alone on a film set, or were the shadow people there? The Roswell aliens just fought the smiling man, I'm told, and his name was Cold. And I can't believe I'm dancing with the fish. Head no fish on Thursday nights with AJ2, and the Wi-Fi's helping me all through the night. All I ever wanted was to just hear the truth, so the Wi-Fi's helping me all through the night. The Mothman sightings and the solar storm still come to Agatha, the secret city underground. Mysterious number stations, planet Earth 02, Project Stargate, and what the Dark Watchers found. In a simulation, don't you worry though. The Black Knight satellite, it told me so. I can't believe I'm dancing with the fish. Head no fish on Thursday nights with AJ2, and the Wi-Fi's helping me all through the night. Camels love to